And there we go. Hello, everybody. My name is JJ Asghar. I'm a developer advocate for the IBM Cloud. You are watching the IBM Developer Twitch stream and soon to be YouTube video because I always push these up to YouTube too. I'm here with two good friends. I think it's safe to say we're friends now, at least. You want to say hi?
Yeah, I mean, other than you shutting me out last week, we're absolutely friends.
Nice.
My name is Jason Dobies. I'm a developer advocate at Red Hat working on open source stuff. And I missed last week, but I'm actually quite glad to be back this week.
Awesome. And Brian.
Hey, and I'm Brian Tannous. I've been on the stream the past couple of weeks. Didn't get shut out like JJ, so I mean, I guess I'm on better standing. I don't know. I'm also a Red Hat OpenShift developer evangelist. Yeah, today's going to be interesting.
Oh, my angle's off. My Red Hat is just outside of screen. I'll have to move it at the break.
Don't worry. I got one to cover as far as. By the way, Brian, you're a Texan. Texans got to stick together. You know, that's the way it works, right?
Makes sense. Makes sense. It's probably the reason why I was on the call last week.
Not the first time I've been shut out for being from Jersey, so I don't take offense to that.
Oh, that's awesome. That's awesome. Well, today, traditionally we've kind of just played around in OpenShift. Like, I make it very clear to everyone who watches the stream or the videos. Part of my job is I am supposed to be, sitting here learning how to use this technology. Well, I use my streaming time to do my engineering time so I can learn the technology so I can talk about it. So I bring people who are smarter than me onto the stream to kind of teach me the things they're doing. We've done very basic stuff. These maybe fifth or sixth one we've done now. And we are now actually getting into the realm of the more advanced topics. And we're going to be spending some time with operators inside of OpenShift. Now, luckily, there's a gentleman on this call who might have written a book on this. So Jay, do you want to talk about your book and what you're kind of hoping to get out of this stream?
Yeah, so you may see some completely obviously placement of my book, and then Brian's actually got quite the setup there. It's funny because I was telling him off camera, I've been horrendous at actually talking about it. Like once, this is the first time I've ever written a book. I've always wanted to do it. And once it actually got released, I forgot it in all of my status reports and things like that. My co-author, every time something came up and we're trying to talk about, specifically we were in this planning meeting and we're talking about documentation assets. And I'm going and I'm pointing at things. And he's like, I cannot believe you haven't mentioned the book yet. I was like, oh, right, we did that. I just kind of was like, I'm shutting down. No, but I'm not on here to shill my book. But in terms of the context, I'm going to be been doing operator type presentations for years now. And I'm doing a couple in the next couple weeks that are a little more course driven, and that's much more my speed anyway. But I want to use this time to kind of go over some of that. I mean, I've been just prepping it, so it's going to be writing operators, going to be running them. I like having JJ here new to it, so that way anything I take for granted, he can stop me and be like, I don't know what that means. So this is a good test run from a new user, new technology standpoint. It's also cool because JJ is a developer advocate I've never presented with before. So I've never seen his style. I'm saying he, I don't know if I say he or if I say you or how I say this, but I've never seen your style. So I think that from a, hey, try this, try that type of thing. Like for instance, one thing I do want to hack on while I'm here, there's a couple of different parts where I copy code from an existing file. I copy an existing file into the tree because no one wants to see me write a Helm chart on the spot during these particular courses coming up. So I've been thinking I'll probably throw together a quick bash script that does the copy for me so people aren't seeing me traverse my directory structure. And the other option was, do I symlink it to just home/x or something like that so I can quickly get to it? So little presentation-y things like that I'm curious to see where the conversation organically goes to, because I don't know about you two, but the more I've been in this role, the more I find I'm paying attention to people's style than I am necessarily the content these days, which is a good thing in a lot of ways. So I'm already getting off track, and this is one of my biggest issues. I've probably mentioned on the stream before, I teach courses at Villanova University. I have the students do 5-minute presentations on something they're passionate about, and that's all. Just pick a topic and talk about it. And it's mostly because they're not comfortable speaking. And, I graduated college thinking, I'm like, all I need to know is how to do is write code. I don't know how to need English. I don't need to present. And I thankfully had a mentor on campus who was like, no, stupid, you are going to need to actually learn how to write. And she was pretty adamant about it. And I've went back to her a couple of times in my career, and I'm like, you were right. This is actually much more beneficial than I expected. So I want to give my students a chance to present, because I don't want them to hit the ceiling cap of being like stuck in a cubicle and never being allowed to talk to people because they just can't do it. So I'm like, you pick the topic and just see where you go with it for 5 minutes. And it teaches them that 5 minutes is a lot shorter time than they realize, because you could see some of them are like, oh my God, 5 minutes. I'm like, I guarantee you I'm going to be waving stop at almost all of you. So this semester, we obviously had to do them online, which was annoying in the sense that it's a fun class to do. Like, we are laughing at a lot of these. The class is engaged. It's arguably worked better online because people were in the chat room a lot more than they would have been. And I was completely fine with that, like make comments during it and stuff like that. Point being, styles. So one of my students last semester, and you had to be there, but I'm going to try to explain it anyway. So he went last, and I see him with his laptop out, and I'm like, all right, this kid's not paying attention. This is 3 hours in. We've done 28, 29 of these. This is going to be awful, but he just never volunteered to go, and the way things worked, I called on him last. So he gets up there, and he's got this, I don't even know how to describe the style. It's this kind of deadpan, half serious, but he's joking tone. I'm trying to think of a comedian to relate it to, and I can't.
So British?
I mean,
yeah, like what?
And he's going on, and you kind of don't see where the presentation's going, but he starts to lean into this idea that walking sucks and walking is lame, and as humans, we have not evolved past it. And he's like, so my idea is that we should all be using wheelies, like the shoes with like the 2 wheels in the heels.
Oh, that's awesome.
And he pulls up this slide, and it's got a couple of pictures of wheelies and like variety of like zoom, and it's got fireworks and a bald eagle and Obama and an American flag. And he had the entire class absolutely rolling. And we were all super into it. And like, his point was obviously joking, but it didn't matter because it was entertaining. And I actually did something similar a couple months later at Code One out in San Francisco. So I had to do booth demos. I don't know about you guys. My absolute least favorite thing to do is booth demos. Like, you put me in front of 8,000 people, I would be happier than putting me in a stupid booth demo. It's just the worst possible situation for me. Because I don't like the audience comes and goes, and you get so disheartened when someone like looks over and then they're like, no, this is not worth my time, and keeps walking. And you're constantly doing that math every time someone walks by, and you're like, shit. But I was like, you know what? So I emailed him. His name is Andrew. I'm like, can you send me that slide deck again? I want to model my slides off of it. And I did. It was actually an operators talk leading up to it. And I had this, a couple of tongue-in-cheek slides in this big bombastic one where I put Jeff Goldblum. It was the same thing, kind of random type stuff. I had a quokka because that's big in my family. I had like fidget spinner, and everyone who walked by looked, and they're like, I kind of got to see what the hell this is. So they wandered over, had a decent enough crowd, engaged with them. Like, people were taking pictures, so I would stop and pose for them because you got to take a picture of that stupid ass slide. Point being, all really long way of coming back to, like, I tend to pay a lot of attention to people's presentation styles. So I'm curious, one of the other things going through this is going to be kind of your feedback, both of you, on how this works with me largely presenting out of a terminal. If you have any things you would do that are different or typical tips. I don't even have my notes up, but I'll have to pull them up at some point. Like, are you the kind of keep the notes off to the side and copy and paste them in type of thing? So by all means, stop and interrupt me with that stuff. I'm not doing this as this very canned demo. This is a cool, let's make this a bit of a presentation developer advocacy type side lesson to all of this.
Awesome.
All right. I was going to share my screen, but actually let's talk about what operators are first.
Yeah. Good question. What's an operator and why do I care?
So, and I'm totally willing to answer that, obviously. Did you know the term before I brought it up as a potential topic?
So I have been exposed to operators in the sense that, in my mind, when I was taught them when I was first learning Kubernetes, an operator is something to interface with something else outside in the Kubernetes natural language, if you will. So if I had to, like, there was a MySQL operator, I had to talk to a MySQL database. And if you built an operator inside of Kubernetes was a MySQL operator, it knew all the bits and pieces, all the APIs, right, to talk to MySQL. Is that accurate?
That's not far. It's certainly not bad. It's definitely, I'm not coming out saying, no, you're wrong. Let's start over. And the reason I kind of ask is, so I just put over in chat. Yeah. Someone mentioned they also thought that communication wasn't important. It's funny, like, what you think in college. Like, so I graduated in 2001. So I had been watching all of the Y2K stuff and being like, sweet, I'm gonna go out, I'm gonna make my millions. I was like good in school. Like I got good grades because I was a school nerd. And I'm like, yeah, I had an overinflated sense of how smart I was. And then I got into the real world and just bitch slapped all over the place with like so much more knowledge than I possibly had. I'm like, all right, we're gonna cater the course around that. And I'm trying to tell them, I'm like, it's not even just my role, like a sprint review. And I make them do that. Oh, good. This is even perfect that you're in college. By all means, focus on that stuff. Because even outside of presentations or streaming or anything like this, if you find yourself in an agile process, which many shops are these days, you'll do sprint reviews. And the way to get your contributions noticed by other people is talking during them. So how do you come into a sprint review and let's say you're on sprint 50? How do you quickly paint the context for people who don't know it as intimately as you do? And how do you bring them up to speed quickly so you can show them the new stuff and then importantly sell it to them? So in the fall, I do senior projects and I make them do sprints every 3 weeks. And they all kind of like hit this point of like, all right, so we've got a database and I can add stuff to it. I'm like, yes, it's valid work. I was like, how do you sell that better next time? And then we kind of talk about like, how would you demo something that doesn't have a UI front end in front of it? So something like the database. And how do you suddenly explain to someone? I'm like, I know it, viewing it, what it took to do it, because I've done this for so long. And it's more than, JJ's giving me a look. It's more than just creating a schema.
And also I'm saying, doesn't everybody use PHP MyAdmin? Like that's my GUI in front of a database, right? Isn't that one of just?
Yeah. What else is there? That's all that's available, right?
Yeah, exactly. Come on,
unless
Jay.
I'm using like big data in Google Cloud or Google Cloud or whatever. Like what else am I using here?
It's funny as you say that. I don't know that a student has ever opened that up and tried to show that as the example.
Really?
But let's take it a step further though and say the ORM layer. So we've gotten Hibernate set up to save a couple of Java objects, which to them, and I get this, if you've never done it, especially if you've never worked with an ORM framework, you're like, okay, this is going to take me a while to wrap my head around it. And then, all of this research, and we've all been there, we're still at this point where you do all this research and you're like, oh shit, that was 4 lines of code. That took me 6 hours of research to understand. Yeah. And then they get up there and they're trying to justify that. And I'm like, that's a skill. I was like, how do you tell your manager who may not really understand it that everything you did took a lot of time and you have a lot of knowledge from it? But so I like this. I like this as I keep asking those questions. I'm curious about this other perspectives you have in college or questions. So by all means, keep throwing them out, and I'm happy to tangent off of that, off of the operator side. Okay, so operators. So and this is funny because I had to look this up. We acquired CoreOS in early 2018, and I say I had to look this up because I would have said it was last year. Even before the whole outbreak thing, I would have probably said that, but now time has absolutely no meaning whatsoever. But one of the biggest reasons we bought them was their engineers and their experience and their expertise, which ultimately is kind of why IBM bought us when you think about the fact that we don't have like IP, like it's all open source stuff. So you bought us for culture and stuff like that, which a tangent I don't really want to get into. But they had a lot of experience in automation and upgrades and day two operations and a lot of the pieces that we were missing. One of them was this notion of operator. Mm-hmm. And then over the course of what is now coming up on 2.5 years, the term has exploded to a point that kind of annoys me. People will, it's almost treated as a silver bullet. Like, oh, you're writing an operator. I used to do partner work, and it's just like, every time a new partner would come up with something like, oh, someone internally would be like, can they write an operator for this? I'm like, that's not the question we should be asking about this. And it's interesting because my co-author kind of feels this way too. And even before writing the book, it's not like we're sick of them, but we got into it being like, it's not the answer for everything. But like you look at last year's summit, I'm pretty sure it was our summit, and Matt Hicks, who is now, what the hell's his new title? President of Engineering, or everybody got stepped up. Super smart, super awesome dude. Very, very cool guy to interact with for as high of a level as he is. He's still a nerd at heart and still just a fun dude. But he was up doing his keynote and he's mentioning RHEL. And he did this analogy to, I was going to say a rowboat, but it's not a rowboat. It's a boat that rowers use in college. My wife does dragon boats, something similar like that. Like the long canoes, not like a cheesy little like rowboat like that. Someone with I don't even know what the hell they're called. Like the collegiate rowing. So you've got like the 12 rows or whatever. You can tell I'm so not a sports guy. I'm like the boat in the water and the paddles and the stuff.
There's just 12 people sit in it. They all have rows.
Yeah, and then they go somewhere just to turn around and come back. It's pointless.
You're talking about crew.
That's a bitch.
Crew.
Yeah.
Crew teams. And he draws this analogy to it and the different positions on the boat and their kind of roles. And he has up there RHEL and OpenShift, and Operators was one of the other crew members. And seeing it side by side with the heavy hitters like RHEL and OpenShift, I was like, wow, he's not wrong for the way he did it, but at the same time, I'm like, that's very weird to be describing like, Porsche, Lamborghini, and then wheels as 3 things to mention in a row. But, so I guess I lead all into that because we talk about them, and you've probably heard a bit less of this, but we talk about them like they're magical and they solve everything. It's not. Let's start at the basics. It's a pod.
Wait, what?
And that it's going to run as a pod.
Oh,
yes.
I genuinely didn't know that.
The operator is a pod?
Yeah. The operator itself is a pod.
Okay.
And your reaction is exactly why I start with that. And I've done that for the past couple talks. I have that in my slides for this course coming up. And now I'm super happy I go that route because it's literally a side that just says it's a pod, because you hear it does all this automation and installation management, stuff like that. You think, okay, this has got to be some weird deep hook into Kubernetes that I've got to install some weird way. Now, start the basics. It runs as a pod. Then there's 2 pieces from there. Let's talk about the Kubernetes side first. So it is a Kubernetes controller, which basically means that it can interact with the control plane and set up watches that say, hey, something changed on a resource I care about, tell me. And then it gets pre-configured with a authenticated client into the Kubernetes APIs. So it can react and do some shit from there. Still running as a pod, just has tighter Kubernetes integration than MySQL, for instance. The big piece there is something called custom resource definitions. And these are, again, a Kubernetes standard construct. In 1.17, 1.16, a very recent release of Kubernetes, they finally came out of beta and they're a full-blown supported feature. But if you think about the typing system, the type system, or like the kind is the Kubernetes term. You have pods, services, deployments. Custom resource definitions just let you define your own. So now I can have my SQL database as a custom resource type, and then I can talk about them with Kubernetes like I would a pod or a deployment. So you combine all of that stuff. And again, this all sounds like existing stuff in Kubernetes, and it is, where you have a pod who it gets notified of changes to a custom resource and then
Mhm.
does some stuff to react to that. And that's ultimately the basics of it all. To kind of demystify. Now that I say it that way, I kind of want that word in a talk, like demystifying operators. I feel like would be a great, like, hey, I've heard about these. They sound like they're crazy. So let me share my screen.
Mhm.
All right. You guys see the terminal?
Yep.
Mm-hmm.
And is it big enough, or do I need to make the fonts bigger?
A little bit bigger, and it is a little weird to see that blue on black, but
yeah, I'll fart with that at the break when I'm not on screen.
Okay.
Ultimately, you're not going to really need to know the directory I'm in, and the actual files are going to be in lighter colors anyway, so I can dork with that. I have this like automated generation of them based on my wallpaper, so sometimes it kind of goes on the darker side. That good or bigger?
That's good. That's very
That's
good.
good.
Okay. So, and this is great. The reason I asked this is because I plan on using 3 panes, and I'm not quite sure how the real estate's going to work there, but we'll figure that out. So let's see where to start. Let's start by installing one. All
Okay.
right. So I'm going to hop over to operatorhub.io. This is I can never think of the right word to describe this, and I need to get to it better. I always go to call it upstream, and I don't know that that's necessarily the right word. It's a hub like any other hub that you've worked with online or any other generalized repository, where it is a collection of lightly curated operators for use with Kubernetes or with OpenShift. And I guess let me quickly reiterate on that point. So I've mentioned all of my description so far was about Kubernetes. Since OpenShift is Kubernetes, all of this will then run on top of OpenShift. So I always feel the need to drop in that whole OpenShift is Kubernetes messaging and kind of show that, yeah, it's still going to run there. We're going to do everything on Minikube today, but all of this stuff not only runs on OpenShift, but at some point later, Brian, you know the guts of how machine sets and stuff like that work. When I need a bit of a breather from talking and you guys are sick of hearing from me, you could probably talk a bit about how OpenShift 4 is really architected on them and the kind of benefits it gets us.
Yep.
JJ, you were going to say something?
Well, I just threw the link into the channel, and then somebody made a comment saying that Operator Hub is essentially an app store. Is that an accurate statement?
Only for definitions of store where you don't pay money for it. Now we did just launch Marketplace, where everything is free. So I think that's why I tend to lean into the term upstream, because everything is ultimately free. But you'll notice just a variety of stuff in here, and I'm not going to scroll too much because I know that ends up looking a little bit weird on Twitch, but a lot of our partners contribute to this. I'm pretty sure this is part of the donation that we're doing to the CNCF with the operator framework itself. We're going to talk about that in a bit. But you see a variety of things in here. I've worked with Aqua when they were writing their operators. We have probably a handful of Red Hat ones floating around. I think Strimzy sets up an Apache cluster. I'm sorry, a Kafka cluster, and so on.
We need more Kafka in our lives.
Kafka, Camel's in there, serverless or Knative's in there, Tecton Pipe. There's everything. This is like the best store ever.
Yep, Strimzy's the one we're going to do.
I saw Vault. Let's go with Vault. Let's go down that rabbit hole.
We need Vault?
Uh-oh.
What's a secret?
Well, everything's open source, right? We don't have any secrets.
That is true.
I wish there was a way to see the people in chat and the chat at the same time, but that's all right. I love some of these names in chat, though. The Sysop, Commander Root. Like, this is a nerd audience, and it makes me very happy. Even Babe Cafe. That's it's because that's all in hex. That's like a term used for something, right?
Babe Cafe helped us last week pretty significantly, if I remember right. So nice shout out.
If you're listening right now and you can reply that so it's obviously all in hex, and I feel like I've seen that used for something, and I can't remember what it would have been.
You're thinking of Dead Beef, are you?
I mean, there's Dead Beef, there's Babe Cafe, there's Cocoa Babe with zeros for the O's, and I feel like they use this salt for something, but damned if I can remember why there's something about the fact that I recognize that was all written in hex tells me either A, I'm further gone than I thought, which is entirely possible, or B, I've seen it used in some context. But I love, like I said, Commander Root, like some awesome, he's smiling, some awesome nerd names going on here. Okay. So a lot of stuff in here. I don't know that I really want to talk through too much of it now. We can come back to it, but let's actually do some stuff. So if you go to Operator Hub, it's going to give you some install instructions, which actually ends up being kind of cool because it's all ends up copy and paste. So I'm going to kick that off.
We're literally curl bashing right now.
Oh, yeah. I knew you were going to point that out. Well, I knew it because I did this a couple of days ago. I prepped this part of it where this is actually just a pre-installation step onto Minikube. This isn't needed on OpenShift, and I'll explain why in a second. But I was like, I'm going to do this. I'm like, maybe I'll set it up ahead of time. I'm like, no, I want to see JJ lose his shit when I do this on stream. And I didn't even hit enter, and you just like smell like, and they're not close on the screen. Like you really got to like look longer than you did, but you immediately saw that.
That's so good.
Okay.
So good.
In between the curl and bash portions of our completely horrendous curl bash line that you saw me run, you see this term operator lifecycle management. This is why I love this stream. I knew you were going to pick up on that. Okay. So there's a series of projects in the process of being donated to the CNCF under the banner Operator Framework. And it's kind of what you'd expect from the name. It's a series of tools for writing and using operators. One of them is this thing called Operator Lifecycle Manager. And the easiest analogy here is if an operator is an RPM, OLM, Operator Lifecycle Manager, OLM for short, is YUM or DNF or apt if you want to go the Debian route. But it is what takes care of installing your operators and upgrading them. It even has the notion of channels and subscriptions. So I can say, I want to subscribe to this Strimzy nightly channel, and OLM will keep an eye on it. And when a new operator comes in, I can have it automatically upgraded in my cluster. So think DNF for operators. And what this lovely curl bash command did is simply install OLM into our Minikube cluster. And again, I said that this isn't needed on OpenShift because OpenShift bundles it by default because we use operators so extensively to start with. Okay, second line, slightly less hideous looking than our curl bash is going to be to install the operator itself. I guess I could take a look at that. I don't know if it's worth pointing out now or later, but let's see what's in here. Yeah, you know what? We're going to look at that later. Just because that looked like shit.
Oh, that's a very good question. So, Tanny what? Sure, let's go with that. Asked if there was a SPIFFY, which stands for Secure Production Identity Framework for Everyone, operator with OpenShift. Or no, sorry, is there an OpenShift way to use SPIFFY? He'd love to see an SPIFFY operator.
So, I don't know. I can say that looking at the follow-up to that conversation, if it's a CNCF project for workload identity, tells me two things immediately. One, there's probably interest in writing it if there isn't already. And two, there's so many CNCF projects at this point, I wouldn't be surprised if we haven't gotten to it yet.
Should we start our own CNCF project so we can get a badge? Do you want to see how
right? Where's the CNCF landscape again?
landscape.cncf.io.
I think you kind of get some of that. Maybe if you're talking about like you roll out Service Mesh or Istio and then you're using Citadel and like some of that, like I think gets rolled in, but you know, that's like managing certificates and things like that, right? Like
there's a zoom on the right-hand side. That's how big this thing is now.
Yeah.
I just want to point that out. There's a zoom on the right. It's not a good sign, people. It's not a good sign.
Are these all clickable too? Good God. Yeah. Holy cow. I could actually hear my fans like spinning up harder.
Just looking at the graph.
Yeah. Yeah, so if it's very baked with Istio, they have to have answered it in some capacity in the Istio operator. Now, there are actually good tangent to this. So OLM does support dependencies, and the dependency is at the custom resource definition. So if the Istio operator understands that it needs to use Spiffy, it can say, I rely on the CRD called Spiffy, and then OLM will search around and say, hey, which one of these operators will support a resource called Spiffy, and then take care of installing all of that. It's possible that actually that is really good to know about the logo and high quality, because I'm always searching for logos. It's possible that that dependency resolution is used to install the Spiffy part of it. I don't know. I'm actually really intrigued now, but this, like I said, about this whole landscape thing, there's so much in here that it's kind of like when we need it type of thing, or when the teams come around on it. Now, again, these are donated to the operator framework, and the operator concept are all basic kube concepts. So this doesn't mean that Red Hat necessarily has to have written it. There are other places writing their own operators. I'm starting to see more and more talks coming out about operators that are not originating in Red Hat, which is awesome to see. Pretty sure I saw IBM do one kind of recently. Interestingly, someone at IBM's talking at my Global Cube meetup, in the Philly Cube meetup, in like next Monday or something like that.
Really?
Yeah, Danielle something, I think. Doesn't ring a bell. Then I know it's a giant ass team, so say, do you know someone so at Red Hat? I realize it's kind of comical, but I also figured the advocacy circles are slightly smaller.
Slightly, yeah, yeah. The advocacy team it's confusing. I'm not gonna lie.
Fair enough. Okay, so all of that was to install the actual operator itself. I do a get po, and we can see the operators. Actually, the operator's creating. There we go. Now it's running. So again, it's a pod that's running. So what do we do with it from there? Let's see. So this is where talks intro. Okay, so once it's installed, and this is available on, actually, I think I can get this through.
So wait, so far what we've done is went to the Operator Hub, which is the free app store for all of these things that could run on Kubernetes, and installed OLM, which allows us to get updates and things like that, if I'm hearing you right, and easily roll out operators onto the cluster. It's already built into OpenShift, but on Kubernetes, it's a curl bash, easy installation, nothing too complex.
Short of the vein that pops out in JJ's head every time you say curl bash.
Yeah.
So that first step, this is not going to render nicely over. No. Okay, we're going to skip this route. So that OLM stuff, that's like a one-time install into your kube cluster to get access to it. Now, it's possible to install operators without it. We are going to see, basically after this demo, I think what I'm going to do is just kill my Minikube and then recreate it just to start from a fresh one, because it's so damn fast. It's actually faster than kind of cleaning up like all the commands to clean everything up. But OLM is to facilitate the operators. But really, at the end of the day, it's going to be service account, role, CRDs, and the operator pod. It just does all of that for us. And then we get this running instance. So that's just the operator running. We don't have a Kafka cluster right now because we've just set up the operator that's going to install and manage and upgrade them. To do that, we're going to need to create a Kafka resource. And this is where things really get cool, because part of that installation step of the Kafka, the Strimzy operator technically, creates the custom resource definition for something called a Kafka. That's going to let me start talking in terms of, for instance, get Kafka. And you'll notice it says no resources instead of falling over and saying, I don't know what that is. So if I just type in some garbage, server doesn't have a resource type, named it. If I type in one of these new CRDs, with these actual CRDs introduced by the operator, it's going to tell me no resources found. So if I hadn't done this step and installed the operator, that would have given us the error message. point being, I can now say get Kafkas. I can call create on them, and they're treated through the normal Kubernetes APIs for interacting with these. So we go back to our example here. I took this out of the documentation for the cluster itself. It's not really worth digging too much into. Notice we'll have the 3 replicas for both the cluster itself and the zookeeper. And I'm gonna stop there because I have to vamp over the actual creation.
So I've installed Kafka before without doing this whole operator approach and using Streamz and all this stuff. And like from that experience, like I learned a lot about how Kafka runs and all the things that are needed about it. You have to have Zookeeper to be able to manage some state. You need to be able to go and like roll out, this whole entire like cluster and all these things that are needed to be able to do that. So exactly what you said, like the secrets and all of that stuff, and being able to access it with routes or whatever, ingresses or what have you, right? So like all of these things were needed to roll this out myself. And I remember the pain of having to go and do that manually, or at least following the steps or whatever. And it took a good amount of time. You basically just gave it like a piece of YAML and it rolled out the whole entire Kafka cluster with everything on it.
Mm-hmm. Right. So
where's
couple
Tomcat?
good takeaways.
Where's Tomcat? I'm kidding.
You got me for a second. I'm like, wait, did it crash?
It's not running.
Shit, what was I talking about? Brian leads up to a couple of interesting points here. Is that I created, it was 30-ish lines of YAML, and you see all of the resources getting created. So I can talk in terms of the logical resource. Give me a Kafka cluster, and the operator understands how to translate that into all of the pieces that need to get created under the covers. And in this case, you'll see it's blown out to 6 pods, a whole bunch of services, deployments, and so on and so forth.
So one of the things that I'm kind of curious, you're running kubectl get all, which is like get all the stuff going on in there. Why don't I see like a Kafka dot whatever Streamz or what, like I see stateful set, deployment, pods in that list. So you could run that and get that whole thing there.
Get all doesn't actually mean all. I don't know exactly how it works, but maybe there's a flag to it that I'm missing, but Jesus. Show kind, show labels.
Like I've seen get all doesn't necessarily give me like all of the thing. Like you're not gonna, whenever you run kubectl get all, like that list of stuff isn't gonna include like secrets and
you need to dash all namespaces. Get all
no,
dash
that's still not gonna do it.
Really?
Yeah.
That'll give you every pod service, like deployment spec, replication controller, like those types of things, right?
Exactly. So you'll notice here we see a shit ton more pods. We still see services. Some daemon sets are mentioned here, but like Brian said, I don't think secrets are ever mentioned here. And it just boils down to all doesn't mean all in the sense that of all resource types.
All is like a shortcut for like those things, which are things that you typically interact with when you're building out an app, right? Your pod, the service, deployments, replication controllers, stateful sets, ingresses, load balancers, and routes if you're on OpenShift or you know what I mean? Like those are the things that are part of all, at least from what I've noticed. But it is weird because you're saying get all, and you just said, hey, we rolled out a Kafka that Kubernetes knows about now, but that's not included in all because all isn't all things, which was always weird to me. But that's a weird thing that's important to know. It's a shortcut. Exactly what Ryan said. All maps to a shorter list of resource types, which are those lists of things that I talked about.
However, I'm glad you mentioned that because I've never thought about dorking with this. I can do Kafka, and it's going to do exactly that. The shortcut of the 5, 6, 7 resources it automatically includes plus Kafka. And I think that does make for a better demo. So I've just added that to my notes over here of, I want to be sure to start using this because it's just going to look cooler if I do it this way. So first benefit from doing this on stream.
And that all like Kubernetes or KCTL, like kubectl get all like is something that is inherently confusing because it's not necessarily all. So it's a good point to like mention and talk about that because like that's valuable because some people are like, oh, hey, I'm trying to delete this application I just rolled out, but not everything gets deleted because a secret got created and that's not included. So a lot of times people like have that list of all the things they really do, which would be all, comma, secret, comma, if you're doing Kafka, do that.
Config maps. I don't remember if that shows up.
Yeah.
You're right though, because that's bitten me too. And that's the first time I realized all does not mean all when I've thought I've deleted everything and it's not. And all of a sudden there's like secrets floating around. It's usually secrets. This is interesting though, because like the docs don't even mention all. I'd be curious.
Maybe there's an easier way. Like there's probably a way, I don't know, but maybe I'll try to figure what that is. But the way is like to get all of the things that are in the namespace that you're currently in. Like that's what, I don't know if it's necessarily valuable because like what you're really working, whenever you're doing that, like you're probably working with a pod or a deployment controller or deployment config or replication, like you're probably working with those things. Anyways, not to sidetrack or whatever, but I think that, you know, that's valuable to include that in there. I think that's good for future stuff.
No, it is. And honestly, I'm compulsive enough that I do really want to see all, especially, and it doesn't help that I'm either in a demo situation or a learning situation, but I feel like, I don't know. I feel like if I say I get all, I really mean show me everything in this damn namespace. And maybe there's some complications to it once you factor in CRDs.
Got it. Here, Jay, open up that link.
Oh yeah, from 2017. Okay. It's been around for a while.
All does not.
It's only got priority 2 though, that was kind of weird.
That's close.
I will fix it.
This is like a won't fix.
Ooh, some rules about which resources fall under all, and that page doesn't exist. Nice. No namespace admin level resources. I mean, that doesn't surprise me. So limits, quotas, and stuff like that. No, Clayton commented. Same issue. I'm showing a list of resource types. Yeah, not anymore. Or was he asking that? So when running kubectl get, I'm showing a list of resource types, which does not seem to be the case anymore. Now this is from 2017, so it might as well have been a different project at that point, but
yeah, right.
So Ryan, I just noticed that in the help, there is an option for showing kind. So show kind.
Nice. Kind. Yes, the pod service / deployment apps replica set.
I feel like it did that even without that though.
No, I'm pretty sure it didn't. Oh.
Okay. Maybe that was a thing back before they used to prefix it.
Yeah, they like added that as a default in one of the, you know, Kubernetes 14 or, you know.
Yeah, because that is looking identical. Oh, another bug report for JJ file. That
there you go.
So kind doesn't actually do anything.
Yeah, exactly. I'm fast on those issues, man. I'll write an issue and no questions asked.
It's a good practice. Yeah, I'll bet you this is one of those things that people forgot was even a flag because nobody actually used it.
Mm-hmm.
So wait, did we ever come up with a resolution on why this was closed here? 111. Good Lord, that was a long time ago.
Yeah, I don't know. I don't think so.
Close. Close.
I just think it's just like
that's Kubernetes in a nutshell right there.
Speaking of, it got closed yesterday. So hey, like we're only a day behind. That's not too bad. Although I don't think there's a fix. The short answer is no. There's not a way to do that, I guess. I don't know.
So, okay, so someone was talking earlier in this thread about kubectl get is going to show me all the resource types. It looks like kubectl API resources shows all of them.
Yeah.
And I think maybe this is one of the reasons why all doesn't do all, because there's just a lot of shit in here that I just never really think about.
Hey, horizontal pod autoscalers are important
to certain people, and that's the question of all. I mean, all. It's a problem in the word all, because like it's an opinionated all, but it doesn't actually say opinionated all.
It's a very opinionated all. There's probably a way to like, you know, redefine what all is using an operator.
There you go. Babe Cafe just laid down some Xgargs for us.
Sweet merciful crap. Do I even want to type? I mean, I was about to say, do I even want to type this? But then again, I did a curl bash before. So you know what? We're going to type anything at this point.
That's going and getting everything out of everywhere, right? Because that dash A. God. So we don't want that dash capital A because we only want the current project we're in.
All right. So just.
Yeah.
Okay. So secrets. Service account. Oh my God.
That's probably why all doesn't really mean all, because
I think we might have just found it. Yeah. I think we might have just found it. Why was that doing? Couldn't tell if it was doing a watch or if it just hadn't ended. But we might have just stumbled across it because somebody tried doing this and like, this is useless.
I don't think it ended because there's just so many different types of resources and things like that. There's just a lot of things that are available that are like configs or whatever. You know what I mean?
This is showing events too, though. This is why it blew up so much. Because it's showing up all of the eventing came in. Role binding, pod disruption, budget. I've literally never heard that term before right now.
So if you guys really want to get it all, Babe Cafe wins the race today. But
yeah,
it's important just to know that all doesn't really mean all. And like, that's one thing that we've kind of like talked about before. So in case you use labels and things like that. To be able to define stuff, right? So
this is true. Okay, so pulling this all back, it was a very fun tangent though. We got a ton of resources. Not only did we get a lot of resources for just the simple Kafka creation, there was a timing thing going on where if you noticed it at the time, all of the zookeepers started up before the Kafka clusters. And this is another huge benefit of operators, is that timing-based thing or relationships or this has to do X, Y, and Z before the next step can happen. All of that can be done in the operator, where you can't do some of this in straight up manifests or Ansible or something like that. The other cool example of this is of the other resource types that were created by this operator. They have one created for Kafka topic. Now, I'm going to create this. Now, as I'm saying this, I need a better way of showing it, but okay, again. So the thing is, so it created a new topic. There's no actual Kubernetes resource that corresponds to a Kafka topic. It just doesn't make sense. But the cool part about this as a demo is it shows that custom resources don't necessarily have to map to one or more Kubernetes resources. It's a way of talking to the operator and saying, do something. So I can look and I can say, give me all your Kafka topics. And it's going to say, yes, there's a resource named demo topic. But if I do a k get all, even though we know that that's not actually all, you'll notice there's no new pods. There's no new services or anything like that. So how do we test it? Let's get into one of those pods itself. Topic. That the command. Yes. So if we do a list topics from within one of the pods, you'll see it actually has that demo topic created. So they don't map one-to-one or even one-to-many with Kubernetes resources. And that's another reason why I like this example, because it's really cool to be able to use the kube APIs and the kubectl commands to talk to your operator and have it do things that don't just simply say, give me more pods or give me more services. So I always really like that as an example. One more option, I can then go edit my Kafka instance. I'm going to change the replicas to 4. And set this up before I hit save. And immediately when I hit save, it's going to edit that custom resource. The operator gets the request that says, hey, the configuration has changed. What do I need to do to react to that configuration change? In this case, it understands I have to stand up another pod of the actual cluster itself. So it's a scale operation, but I won't go this extra step here, but it's not just scaling because it's adding it to the cluster. It's doing all of the stuff it needs to do with Zookeeper. It's not just saying, Kube, scale this thing up. It's making it part of all of the logic that needs to take place. And that's really where the big selling point for operators comes down to is, hey, I can't just do this through Kube because there's more logic that has to happen. There's more native application understanding that has to be present. But I don't want to put that on my end user. I want to be able to tell them, if you want to scale it up, fine, do it through the resource. And the operator is going to take care of all of that extra operational stuff to say, I'm going to put it into the cluster and things like that.
It makes sure that like this Kafka is available when you do things like upgrades and stuff like that, or the scaling, right? Like it's making sure that Kafka doesn't go down so that that service that's dependent on Kafka still works whenever you're doing an upgrade, which that's really valuable. And that's something that is kind of hard, like from, you know, deploying it myself. If I try to go and upgrade to a new version of Kafka, like how am I going to probably do that? If I'm just developing a local demo app or something, rip and replace, but like that doesn't work for everybody, because if there's a live app in production, like how do I make sure Kafka is still secure and updated and, you know, has the latest patches for blah, 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 you know what I mean? Like all those things are valuable, which operators help with that.
Okay, so while Minikube comes back up, let's look at actually building some operators. So I talked before about operator framework, and it's this kind of collection of 3 projects that are related to writing and working with operators. We talked about OLM. We installed it in our super secure fashion, and we used that to tell it, hey, I want you to install this operator for us, and it did all of the heavy lifting. And we're going to see a bit of that heavy lifting in probably about a half an hour, 45 minutes. But how do we actually write an operator? One of these other projects that falls under operator framework is called the Operator SDK. And it's a way of scaffolding out a lot of the heavy lifting on writing an operator that you're going to want to do. It's not the only way to write operators. It supports, I'll start with just saying it writes you operators in Go. So we'll scaffold out a project definition. It's going to go on my Go source directory. We're going to write Go code to fulfill it. That doesn't mean you're stuck using Go, because it's a pod and it's talking to Kubernetes. So any language that can talk to Kubernetes and run in a pod can be an operator. And I'm pausing, and JJ didn't jump in and say we could write a COBOL operator, but yes, now that we have COBOL running in a pod, we can absolutely write a COBOL operator to talk to Kubernetes. I know KOPF. I don't know how we even say that out loud, or if it's ever said out loud, but that's the Python version of it. There's got to be a Java one somewhere, since surprisingly we haven't added it to our SDK yet. I can't even say our SDK yet because we're donating to CNCF, but ultimately that operator SDK is one way of doing it, and it would be very nice if it supported more languages. But it's not just Go. We also have the way of taking a Helm chart or an Ansible playbook and wrapping that in an operator for you using the SDK, and pretty quickly going from, I just have these 2 standalone technologies, or one of these 2 standalone technologies, to it's packaged and available and running as an operator.
So that's always been a stumbling block for me. Like, okay, I come back from the configuration management world, right? Where I would use an Ansible playbook or a Chef cookbook to build a web server, right? How, like, I don't fully get why I would use that as an operator. Like, I can't seem to make that logical jump, because for me, a configuration management is to do application, service, and trifecta, whatever the hell the thing was in the Puppet, service, file, anyway, what I'm trying to get is, can you explain that jump a little bit more, why you would use like a Helm chart or an Ansible playbook to an operator? Like I don't fully grasp that.
Sure. So I'm going to talk about, no, that looks ugly highlighted. This in a second. It's a very common question. So I used to work very closely with a lot of our partners. And the biggest thing is that they would come to us and I'd be like, hey, we have this thing called operators, here's what it can do. And sometimes, a fair amount of time, their response was, that sounds amazing, but we already have invested in Helm infrastructure, or we've already invested in Ansible infrastructure, and I'm not maintaining 2 installers for no good reason. So it's meant as not to trivialize it, but it's meant as a bridge to those technologies into operators. So that way, if you're using those technologies, you can still leverage operators pretty painlessly. Now, why would you want to do that? Remember, the operators work in these custom resources. So you can then define Kafka. For example, for all I know, that Kafka one is running Ansible playbooks or Helm charts under the covers. I don't know what it's doing internally, and I kind of don't give a shit. I know that I can talk to it and say, give me a Kafka cluster, create a topic, and it's going to translate that into the right calls. So now, instead of me saying, hey, you want to use my application, go install Ansible and run these playbooks, and here's the configuration you do. Now it's, oh, just install the operator and talk in terms of my resource, which is what you're going to be expecting to talk in. And then we can use OLM and Operator Hub to push those out. And now they sit side by side with everything else. So I'm not saying, here's my playbook, go do it. I'm saying, just take the operator just like you would any other operator, and you already know how to interact with that.
I posted the link or a link in the chat with some of the details on the capability of operators and what you could do. But like, whenever you're working with Ansible, one of the things that I think about is, like, I'm on my like local machine doing Ansible development, to be able to install or configure or set something up, right? And like, that's how I generally would work with Ansible on Kubernetes. I go and, hey, like, fire off, here we go, use the Kubernetes built-in Ansible, stuff, so I could like hook into that and easy access all of that stuff. But the thing is, like, I'm running that locally on my machine one at a time. And Ansible's great, and it goes and checks and says, like, oh, hey, look, this is doing its thing. Like, you could use Ansible Tower and hook up and do all these crazy things. Or you could have an operator that's running on the cluster that you're trying to do the thing on, that's always available, and it's always running that Ansible loop, checking like, oh, hey, we ask for one instance of Kafka. How many do we have available? Instead of like me running that each time on my laptop or having something else. So that's one of the big advantages, I guess, of having Ansible inside of an operator that like I've noticed.
Okay. So I'm glad you found this so easily, Brian, because I was looking for this slide the other day, and I presented it in a dozen different presentations, and I just couldn't find it. Could use this last Friday, actually, when I was talking to IBM. So we talk about this operator maturity model and this evolution from your basic installation, which is what all I'm really going to talk about today. That's what a lot of our demos talk about. We don't really have advocacy messaging around the kind of later phases, although it's on my to-do list. But Helm, you'll see, basically starts there. You can run a Helm chart, it installs some stuff, and then it's done. How do you, I'm laughing at Pave Cafes because you're not entirely wrong. So we talk about, as it gets further up, being able to do more lifecycle management type things. We see our databases support things like backup and recovery. We talk more about, as they get more and more evolved, the operators able to do this kind of workload analysis and make determinations of how to handle it in code inside the cluster rather than me having to manually do it. So why would you want to use an operator over necessarily Helm? You hit a cap on how much you could accomplish in just the Helm chart. And you also, 100% unbiased. Go is not ours.
Well, like one of the things too is like this was done, like if you're talking specifically about Helm, like, we were talking about this in operators, a year or whatever, longer, 2 years ago. And one of the things then with Helm was you had to run tiller and you had to run services on the cluster to be able to do that. And there were some security issues with that, like that needed to be ran as root. And we've talked about that on the stream before. Like, that doesn't necessarily fly with OpenShift because we're talking about true multi-tenancy on that cluster, and we want to be able to make sure that these things run in a non-privileged state and all of that stuff. So like that's all really valuable, and that's part of the reason and part of the way, or reason why you would want to wrap like a Helm chart in an operator, so that you could get that running on OpenShift without those extra components. Now Helm 3 came out, it's a little bit different. The current state of that is all different. And, there's some supportability of Helm and OpenShift, so like that aspect could maybe go either way. I don't know. Some stuff's changed. At least that's what I've thought about it so far.
To this point about the fancy state loop, you're not wrong. Like I started earlier, I'm not sure when you logged in, but like kind of saying that we talk about them like they're magic, and it's not really all that much black magic. It's concepts you've like you said, you've been able to relate it back to a state loop. It's not doing anything all of that revolutionary, I guess is probably the best word for that. It's fairly easy concepts to understand. It's just doing them in such a way to support something. But, like I said, I tend to kind of shudder at how much we talk about them like it's this crazy magic, when you kind of distill it down and you're like, okay, this is not, really that weird to deal with. All right, so
I'm already very confused, but it's cool.
Well, let's write one, and it'll become easier from there. But we'll do that after a break because I would like to run to the bathroom before we dig into the next topic. JJ, I'm going to let you pick those. So we just saw that we can do operators in Go, Helm, or Ansible. I'm set up to, actually, I want to comment on Ryan's point. This is that chart was specifically for what's supported by the operator framework. To the bias question from before, like I said, there's outside projects running for running them in Python, writing them in Java. So don't let it sound like I'm saying the operator framework is the only way of creating, because I'm certainly not. It's just within what is currently supported by the SDK. That's where the breakdown of functionality and capabilities lie. I get too easily distracted by chat. So JJ, I'm gonna let you pick when we get back if you want to do one in Go, Helm, or Ansible. I'm set up to do a sample application in each, and hopefully that'll make it a little more clear. And then we can double back and do either all three of them or just a few of them. But you make the call when we get back from the break, where you want to dig in and where you want to get started on, and we'll go from there.
Sounds good. All right, and we'll be back in a little bit. Give us like 5 minutes. Thanks.
for boom mics for my arm.
There you go. That was a perfect place to kick back on.
I know.
So let me double check to make sure that the thing turns around. Possibly. Everything looks right. My preview isn't saying that we're back live yet.
Mine looks
Oh,
okay.
There we go. Awesome. So hi. Thanks for sticking around. We're back from our 5-minute break because I know I'm an old man and I need to walk around, make sure I can stretch my legs every once in a while. I'm here with two friends here. Jay, you want to say hi?
Hi guys, my name is Jason Dobies. I'm a developer advocate at Red Hat. And speaking of the old man stretching things out, I stood my desk up for this because I'm kind of curious to see how one of these presentations go with me standing on top of it. So mention to me if for some reason I'm like going in and out of the mic because I wobble around too much or something like that. But this is different area for me, so keep me honest.
And then Brian, say hello.
I had hoped that the freedom to move around is better. So hopefully that's good. But yeah, I'm Brian Tannous, developer advocate at Red Hat, focused on OpenShift. And really today we're hoping that we could, convince JJ that he should build an operator and understand what it is.
Or COBOL.
Exactly.
Nice.
That's the goal today.
I like it. Cool. Well, so Jay, you gave me some homework for that quick little break. I do want to see all three of them, and I think it would be valuable to see all three. But being that I come from the configuration management wars, we should probably start with Ansible because, and also I think the Ansible one probably be the easiest one for everyone to understand because the YAML-based install or build or whatever what you're doing, I'm assuming is pretty straightforward. Is that accurate?
Yeah, I'd say so. To the point that I don't expect to put a ton of time into explaining the actual Ansible. That's not the interesting part. The interesting part's how you package it.
Perfect. Let's do that then.
All right. Oh shit, I got to share, don't I? All right. So you should see my terminal again. Hopefully the colors are a little bit better. Let me get my notes up for that. This is so weird because, like I said, I'm prepping this for like a formal course, and I feel like on edge when I like break character like this, but I know this is a stream where I don't need to be 100% on. All right, so 2 ways to do things with the Ansible-based operators, and I'm going to keep trying to use that terminology because when I say Ansible operator, it's a bit misleading. It's really an operator leveraging Ansible, or that's going to call a role. So I could point it at an existing role, and it will pre-populate all of the necessary pieces for me and just kind of pull in the Ansible files. Or I can use it to create a brand new one that has a blank role that we can fill out. So let's start with that.
Okay.
So yeah, that went faster than I expected it to. Let's look at the command. So we have this operator SDK. I'm going to tell it I want to make a new project or a new operator. The application we're going to be doing is this fairly simple visitor site where if you go to the page, it's going to throw a table up that says timestamp, client ID, stuff like that. And then you jam on refresh a few times and new rows appear. Nothing too fancy. 3 applications being deployed. So a front end written in Node, a back end written in Python, and then a MySQL database. So we'll see 3 things get created, services available for each. And that's really enough complexity, I think, where we're not just deploying a single pod where you're like, this is dumb, why would I use an operator? There's minimal timing things going on where the database should be up before the backend is started. Mm-hmm. And you could kind of snowball that into a serious discussion on container native development or cloud native development that you shouldn't necessarily rely on that. And the backend, if you stand it up later, will still try to reconnect to the database. But for all intents and purposes, this operator's got to stand up a database, it's got to stand up the backend, it's got to stand up the front end. Mm-hmm. And so visitors, Ansible, I'm telling the SDK, hey, I want you to make me an Ansible operator. I don't like these terms, but API version is, I've been criticized for saying it this way, but I'm going to say it anyway because screw it. No one's on here who would criticize me. It's a namespacing and versioning construct, the API version. So namespacing in the sense that you'll commonly see these contain namespacing information. So redhat.com or Couchbase or whatever. But then it's also the version string. So new versions of the operator are going to do something with this. 1.0.0, 1.0.1, and so on. I've gotten in the habit of using V1. That's probably not even the best way of doing it. There's no, it depends if you want to get into Semver and this whole argument that I'm sure we could have knowing this crowd and really go into. But for now, let's just call this V1 and move on with life. And then kind, which is the Kubernetes word for resource type. So again, if I create a pod, it's a kind pod, or it's of kind pod.
Like the Kafka one you saw earlier was kind of Kafka.
Kind Kafka, right. It's wonky to say out loud. It looks a little better in writing, but conceptually, this is the resource type we're creating, is going to be called resource, or called visitors. So let's take a look at what got created. And that was not useful because there's too much stuff there. So let's start here.
So hold on, all those extra flags, like those are still available if I wanted to make a Go operator instead. Like it's the same. I just changed the type or whatever, right?
Not entirely. For Go, we're going to use those flags in different follow-up commands. For Helm, it's going to look almost identical, if not identical, except type is going to be Helm. No surprise. Because we're doing two steps in this process, which will be more clear in the Go world, but we're generating the project skeleton for the operator, and we're creating this custom resource definition. And you may be thinking, well, yes, it's two steps, but why would I do them separately? It's because you can do multiple resource types for an operator. That gets kind of ugly-ish in the Ansible and the Helm world. So if we look at this watches file, this is effectively mapping our custom resource definition, which is this API group in kind, again, namespace, version, and type. And then this is mapping it to the Ansible role that's going to run. So I could have multiple entries here and do multiple custom resource types. We're not going to for this, but the way the SDK works with those flags, it kind of pulls them all into one. Okay. So build, I don't want to get into. Let's take a look at deploy. Excuse me. So earlier we installed the, earlier when we installed the Kafka operator, we just created the Kafka resource type, and that, the Kafka resource of kind Kafka resource type. And that was it. We just had the one YAML file. What OLM did was actually install all of these, plus the actual CRDs. Without taking a ton of time to go into them, the service account, the role, and the role binding are all auth-based things. By default, the SDK has given us a fairly permissive role. So you could just take a look at ballpark in the middle of the screen here. For all of these different resources, we have every verb imaginable. That is not good to leave. So remember, this is the beginning of a scaffold. We absolutely want to go into here and start dorking with these to limit them as much as possible. But for scaffolding purposes, this is cool. I actually like this approach because it's easier than trying to add. It's arguable. I mean, depending on how you want to approach it, if you're the type of person who permits everything and then restricts, or if you restrict everything and only permit as needed. Again, religious arguments that this group could go entirely down a rabbit hole.
So if I'm trying to kind of understand this, you generated all these files with that command, and now looking at this role.yaml, there's all the different verbs that are in here, and by default, this generated the ability to provision those things on Kubernetes, and those are, say, permissions of the operator?
Yes. So right? We created the service account, or I'm sorry, it generated the service account YAML, which I haven't showed you, but just bear with me that it's a service account, plain and simple. It's going to get a role binding to this role for that service account. Now think about it. The operator is going to be creating some of this stuff. For Kafka, we saw it create pods, services, deployments.
So like It's saying, well, like what? So it's saying that, hey, I could create, get, list, patch, like inside of my operator for all the resources that are in here. Like we would want to trim this down. Like
100% want to trim this down. Yeah. Yes.
But that's what this is like the permissions list and what those things can do.
And what I'll even narrow that down further. This is the permissions list for what the operator is going to be able to do.
Okay. Yeah, I mean, I'm just trying to make sure that it's completely clear for everybody, because this is kind of confusing if I had no idea what this is.
It is. This is just ugly as shit to look at until you've really had to kind of dork with one of them on your own. And I'm liking the chat comment right now because we're dorking with Rareback right now. This is the way the API groups work, that they've sectioned some things off. But if we go through this, you'll see, a variety of resources listed by default. Replica sets, deployment, actually it's listed up here. And then these verbs, this is, if not the full set, you could just kind of eyeball this and realize this is plenty to be dangerous with. Mm-hmm. But again, it's going to need some of these, because if my operator is going to be creating new pods, then I'm going to need create, delete, get, and list right there. Probably going to want patch and update too, because I'm going to have to potentially change those running pods if the I just read it too. It's going to have to change the pods once they've been created. So takeaway here is that we do need to create RBAC permissions for the service account that the operator runs as. The default in the project generation is do everything.
Mm-hmm. JJ style. Give everyone admin.
Do it in production. And then it creates this CRDs directory, which is definitely worth looking into. So if we look at the CRD itself, and again, you'll notice some of the terms that we saw earlier in terms of the API version and the name of the kind itself. It fills out a fair amount for us. It always strikes me as funny when they generate the plural and the singular and that kind of stuff. Although in hindsight, it's wrong. I'm sure we can dork around with this. We'll call one octopus later and just see how it reacts. What we're going to want to do in here, we're not going to do this until a later part of the demo, is implement the spec and status. Now, spec is going to say, when you create a new resource of type visitors, these are the fields that you can enter. Right now, you can enter anything you want. And that's not a security risk, though, because it's not going to do anything with the values. So I can pass in foo equals bar, and the operator is not even going to look at the spec to say, give me the value of foo. So this isn't like a open-ended, SQL injection type of avenue. But it does mean you lose out on validation. So if I try to create a visitor's resource and I pass it a whole bunch of parameters, Kubernetes is not going to say, hey, stupid, you're not allowed to pass me that. Or more importantly, if I make a typo. So if I'm supposed to call a variable host and I call it hosts with an S, if the validation's in place, Kube is going to pitch back and say, look, that's not a real variable that you're supposed to specify, fix it. So we are going to want to, once we productize this type of thing, which is really just during development, it's either a productization step, put the validation in and leverage Kubernetes' ability to validate these resources for us. For now, the takeaway is we are getting a visitor's resource type that will do something in Kubernetes. In fact, let's take a look at it now. So we'll say get, so I have no CRDs loaded in Kubernetes. We'll add that in. And then I can say, give me the CRD. So that's going to give me the access to say, give me all of the visitors. And it's going to tell me no resources instead of I don't have a resource of that type. Now I'm doing that because I'm going to show you this next step too. They also give us a sample custom resource that we're going to want to flush out. And all it really does is default the kind and give us a default name. But I can kapply or kubectl apply this file and it will create a visitor's resource. At some point, I'm going to go in here and edit it with examples for my particular resource once I've defined it. But let's create it anyway. So I created that resource. And again, the type is now in there because I gave it the definition. I've created a resource and you'll see it's there. And that's it. It's fine. Kubernetes will let you do that. The thing is, there's nothing listening for resources of that type. So without my operator, at the end of the day, this is just built-in kube constructs. It's kind of useless at this point, but I absolutely can start creating resources without the operator being there.
So you just like are specifying the custom resource definition of the example visitors, giving it some config, but there's nothing actually doing anything with that config.
There's nothing doing anything with the resource type itself.
Yeah.
So no one was even notified, hey, we have a new visitors resource. So nobody just did anything. So it's not even like regardless of what I put in here, absolutely nothing in Kube right now is wired up to listen for resources of type visitors.
Okay.
Makes sense. At least not yet.
Oops. Exactly. And that's the part we need to write. All right. So let's delete that. We'll leave the CRD in there because it's got to get there eventually. That's good. That's good. Okay, so that was the deploy directory. The one thing I didn't cover in here is we talked about the service account the operator is going to run as. We talked about the role that's going to grant permissions to that service account. And the operator YAML is just simply a deployment for the operator itself. Because remember, the operator is going to run as a pod. The missing piece in here is, you'll notice it says, hey, I've given you everything except for the name of the image because you haven't built it yet. So at some point, I'm going to have to go back in here and actually give it the real image name for whatever operator we build. But those are the, oops, wish me fat finger Vim. So that's all in deploy. RBAC, the actual operator deployment itself, and then our custom resource definition, and then an example custom resource. Molecule is testing stuff. We're not going to cover that because testing is for wimps. Those come in two roles. I'm going to get a lot of hate for that in chat.
Yeah, you are.
If we go under the roles, you'll see a pretty standard Ansible role here. And now I can actually run the tree. And it's just going to stub out a lot of the stuff for us. Now, if I remember correctly, these are all pretty empty. Tasks could be interesting to look at. Yeah, and it's simply saying you need to implement your stuff here. So this is where we would drop our role. And again, if I had given that role at the SDK creation time, it would have pre-populated that stuff in here. But for demo purposes, let's say we're starting a brand new operator. We're going to write and test our role directly in here. So this is where I need suggestions from you guys. So I guess breaking presentation term for a second. I have, it's not, okay, it's not even in here, that's fine. Okay, so I have this role pre-created. What the hell is different in here? Oh, local, okay. This is what I did when I was testing. This is the example used in the book. During the actual formal presentation and not a stream, I'm going to want to copy all of this directly into the new operator. Basically because nobody wants to see me type out all of, actually just everything in there. So I separate them out into different files and stuff like that. My current thinking, I was thinking of writing like a quick script that will say, copy Ansible, and then it'll just know the directory and then copy it to the local directory. That's probably the easiest way of doing it. And then I can customize it.
Are you assuming you're going to be not attached to the internet at all?
No, I'm not necessarily making that assumption.
Okay, then I would totally just put this into a Git repo that you would just check out. Then you could also share it with other people. So they could, and also people like looking at code through GitHub also, right? So I'm saying putting it on GitHub, and then you can actually have the history there too if you want or whatever. So students can take a look at it too, right?
Yeah, interesting. So it's on GitHub as the full
maybe like
operator itself.
You're copying Ansible part over is like you switch to like the Ansible dash step 2 branch or something.
Oh yeah, that works too. That's a very good idea.
Instead of copying and paste, so you could stage it in branches on your code. Like that might be okay.
That's a cool. Can I do a git clone and specify the branch at clone time, or is it a 2-step process to clone and then
That's
check
a 2-step.
out? Okay,
I'm 95% sure of that.
Yeah,
that's a cool idea.
There might be a way. I think generally
we're all Googling right now.
Yeah.
How do I clone and get specific branch? Dash single branch dash branch.
Yeah,
there you
get
go.
Clone dash B, specify branch name.
Okay. So
yeah, that's a cool idea. That's an easy way to like switch between stages of the demo too. So like you could give it Ansible, like if there are multiple things that you're like building.
Yeah, and then just check out. So I would basically branch. Okay, so let's do this live. I'm going to regret using that as the name, but
you'd want to make sure that like, well, I mean, is like, so if you want to make it like from the beginning, this is the operator demo, ask somebody in the audience, do we care about Ansible or Go or Helm? And then like from there, you would have a branch that would be like Ansible 00, Helm 00, Git 0, or Go 00, you know?
Yeah, I see what you're getting at. The thing is, and I can ultimately change this, but I don't have just one repo with all of them.
Repos are free.
3
No, I know. I have. So I'm thinking out loud and also stupidly looked at chat. I have one repo for each. So the visitors Ansible operator, Helm operator, and then just visitors operator.
You could do that way too. Yeah.
Could make one just for the talks, but I'm thinking here, so you're saying I would just make the role branch, and then I would just move. All right. So you're saying I can get RM star.
Because like if you're doing it that way and like you're trying to have people work along too, they could start on like Ansible 00 or your Ansible repo for this, and then like step 00, that's where they start on, and they could copy what you're doing, and if they get something wrong, they could do like a git diff on that branch, or the next branch that they're building on top of. So I think that's kind of a cool way to do it.
That is a cool way of doing it. Maybe not for this particular one, since I really just need some of these files, but I like where you're going with that though, of having a demo app for a presentation done in steps like that through branches. That is kind of cool.
And it forces good hygiene with Git too. So people, especially when people learning, was always be able to walk through the different branches and do the different Git commands and know how to use Git even more advanced, if you will, through the process, which is good. People always need to practice using the Git commands.
I think we covered this a couple weeks ago that I never remember to do this ahead of time. Stream.
Can you dash U?
Okay.
You don't have to do set upstream. Just dash U.
Oh, is it? Okay. I mean, at that point, like I said, I never remember to do it on the first try anyway. So, all right, so let's go back to master. All right, so we'll call this existing. All right, so this is the new one that we're working with. So visance is the one we just created. It generated for us all of this sample role that I'm just going to toss. And I'm going to git clone. And I'll have this better saved. Branch. Oops. Yeah, that's going to be a problem though. All right, so I'm going to have to fix how I check it out so I don't get that extra directory. But this kind of works though. because this is exactly what I wanted, to take my existing files, dump them in place, and then talk through them. So if we look under tasks, you'll see all of the stuff it does. That's cool. Actually, I kind of dig that. And then I just need to have the clone commands off to the side.
Yep. Take your notes and just copy pasta it in. You'll be good to go.
Yeah. And then again, just make it available for, I mean, I'll have the slides are given out, and then I can have, hey, this is the full repo for it. And then that's kind of cool.
Yeah, I agree. I like that. I like that way. It's easy. And then anyone can follow along really easy too.
I think that'll be super neat for follow along things, like a longer lesson-y type thing that's meant to be followed along with. That is a kind of a cool concept. You can see all the pieces. Okay. At this point, I'll very quickly go through. I'm not going to go through all of them, but nope. So at this point, it's just normal Ansible. So this is a role that will run 100% by itself outside of the operator, using the same constructs it normally uses. So the normal variable substitution, including not having to change the case of these. The operator is going to do this for us. So I can stick with normal, very valid Ansible, and everything's going to be fine. And since I copied it all over, it should have, no, vars. Yeah, okay. And then my super secure passwords, but again, that's not the point of this because generating these is possible and the operator is not doing it. So let's leave this where it is. Actually, let's go to defaults.
Yay.
Don't worry, we're not actually going to see that though. And if we see that, something's gone wrong. Don't worry, I'll get you back in there. So despite our little tangent, what we've done is implemented the role. And again, that means either pulling it in from something. And another reason I kind of like this Git example is because it lets people, it talks a little closer to people using an existing version control setup for their Ansible roles and says, hey, this is a possible like minor little build step to say, just automatically check it out, dump it into the operator, build it and go from there, not go language. Okay, so that's the role. And then we have this watches file, which I'll talk about in a second. Let me make sure I haven't missed anything here. Because like I said, I've only really run through this once. Okay. So pretty much that's all it takes for the Ansible operator. And again, if we didn't do the tangent, that's even faster. Or if I had told the SDK, here is the archive version of the playbook, it goes even faster than that because then it's a single line, everything's dropped into place for us. I haven't written any Go code for Kubernetes, no controllers, no anything like that. I'm just starting to focus on the stuff that I care about. And let's be clear, I'm not trying to say this is mind-blowing that it does this. This is what an SDK should do. It's just, it does, and that's good. So now we want to run it. We could build it as an image, push it up to quay.io, and then use those manifests we looked at earlier in terms of set the RBAC up, get the operator pod running. There's a faster way of doing it for development purposes where I can run it as a process directly in this terminal, and it will connect to Kubernetes and field requests as if it was running inside of there, which is super handy when I'm iterating on things and I don't want to be build an image, push an image, rebuild everything. And I absolutely, this method ends up being super cool for it. First thing you need to do though is change this watches file. Now what watches is doing, and I talked about this a bit earlier, is saying Kubernetes, or the operator really, when you get told there's a resource of type visitors, you need to run the role called visitors. And again, if we had multiple resource types, this would be a little more interesting. But for now, we're just mapping internally inside of the operator. Problem is, when we run this locally, the paths are not there by default. So we're going to need to tell it /role/visitors. So in other words, here's the full directory to where the role is located, and that should be enough. So we're going to tell it to run. I want you to run local, which is to say outside of the cluster. Run, meaning run the operator right now. And then watch this file. We're going to hand it local. And so far, so good. We didn't see any immediate errors. And usually, like I kind of showed earlier, the first thing you would run into is I forgot to deploy the CRD. Because without the CRD, there's no way for the operator to then bind itself and say, hey, I have a watch set up inside of Kubernetes to tell me about these resources.
Okay.
This is also going to be interesting because we're going to see how well this works with the zoomed in fonts, because I normally have much more screen real estate, but that's okay. So we'll go under the deploy. So we've created our CRD or deployed our CRD into Kubernetes. It can now speak about visitors. We've started it, which is an equivalent to building the image and starting the operator as a running pod. So now we need to create a resource of type visitors and actually have the operator do something. So we'll go under here. You know what, new plan, hang on. And again, it stubbed this out before it knew anything about it. So we'll call this Twitch example. We only want one backend. And the title is going to be, hi, JJ. Just to make you happy, because yes, got to have your mention in there. And again, this is what we would be doing as an end user. So we're testing the operators that an end user would. They're not going to know all of the fundamental stuff underneath it. They're going to know, I want a new type visitors or a visitor site or whatever I choose to name it whenever I go through this example. I tend to mess it up every single time. And we'll go back here. We're going to say apply. So we've created the visitors resource. You see the operator kicks in and starts doing some things. You see, I'm going to cancel this for 1 second. Now that we know I can do that, comma visitors.
And that looks like the standard Ansible like output, right? Like there's
exactly.
That's what I would run locally on my machine, I think.
No, that's exactly right. That's exactly what it would look like on your machine if you were to run this role directly. So it executes the Ansible that I've handed it. And you'll see it started to create roughly what I discussed before, that it's going to have a database running. We're going to have a back end, front end, a couple services for all this stuff. We'll ignore this. This is just a Minikube one because I'm doing a get all. It's created deployments for all of them. And yeah, it's where the screen real estate's really starting to bite me. One more. Is that still readable?
Yeah.
Okay. And I did the comma visitors, but it's not showing up because of length. So let's go to down here. You can see, hey, we have this Twitch example made about a minute ago. So we've now had this operator that we've created a single resource of, and it's done and blown out to all of the necessary internal components. Shoot, I was going to go mention something here. Shit, I forgot I lost it. Oh well. So grab the Minikube IP. If we go there, we can see our site, and then I hit refresh a few times, and it's sending the request into the front end. Front end is then handing that off to the back end to say, hey, we have a new visitor, store the information. That information is then stored in the MySQL database. Let's try messing with this now. So I'm going to go to, yeah, that's fine. No, let's do this instead. So we'll change the title. And we'll jack up the size to 2. Now, again, that size, the way I have it defined, is the number of backend services. When I do this presentation later, I'll probably have showed the running application first, so that'll be a little more clear. But we hit that, and we hop over, and you can quickly see that the Ansible kicks into gear again. we should see the new backend server starts coming up. And thankfully, after that first download, it all flies. So since I won't be rebuilding Minikube after this, the rest of these should be pretty quick after that. So now we have 2 backend services. We still have our front end. And if we hop back over and hit refresh, Brian gets a mention. And now I don't know enough about Minikube, but I know in OpenShift, this will reflect which one of the 2 backends is being connected to.
Oh yeah, everything that you're getting is probably like all natted, and that's why you're seeing like the NAT gateway IP as a client. Yeah,
which is fine. I don't have to point that out otherwise. It makes for a neat scaling demo when I do things like this, and you can see the load balancing kick in. But
on a real cluster, you would get that.
Yeah, exactly. On the OpenShift clusters, it always happens, so it's fine. But the point is, you can see that the 2 pods were there, and then delete it. We delete our custom resource. You'll notice the operator didn't do anything, and it doesn't have to. All of this happens. So inside of Kubernetes, when these resources are created, the parent resource, and I might be misusing that term, but the concept is still the same. The parent or the owning resource is the visitor's resource. Every one of these things created, the pod, the services, all of that is a child or owned by, I need to look up the terminology. Point is, garbage collection kicks in. So I deleted the visitors. It doesn't even need to go to the operator to do anything. The normal garbage collection for the resource kind of kicks in from there, which is really cool. There are ways of intercepting it, though. I can say, no, I want my operator to be triggered before the thing gets cleaned up. But it does make for neat when I accidentally kill the operator before I've cleaned up, and I'm like, oh shit. Thankfully, Kube can do most of it on its own. So a long, blown-out way of getting to the fact that we ran one command to generate the project scaffold. We copied in our role manually, which is just for demo purposes. And then we basically ran it as an attached process, and we're able to create resources and have our operator logic kick in.
That's pretty impressive. Like, that really is.
All right, questions? I'm sorry, I'm treating this like a class at this point when I get into my question state. All right, so let's do the Helm one next because it's going to be very similar. And then we'll probably break for the Go one because that's going to definitely be more involved.
Okay.
Cheat sheet. Helm. Okay, so same thing. We're going to start in our Twitch directory. We're going to generate the scaffold that I'm going to copy pasta over.
Looks exactly the same minus the Ansible.
Exactly. I thought I had, maybe it's a second example. Yeah, here we go. We are going to do one slightly different.
I've been paying attention.
No, you are. I need to, this is where I'm going to have to time myself before I actually do this one live because I intend to do the Helm one twice. You're right. You're absolutely right. Your comment that it looks just like it. Here, we're actually going to say, hey, download this Helm chart on top of it. And it points to an archive. Yeah.
Jake, we have a question. What is the main advantage of wrapping a Helm chart in an operator?
Yeah, so there's a couple. I don't have to have Helm downloaded. Do I even have it here? Yeah, so I don't even have Helm running on my machine, and I'm able to deploy this visitor site application that is built off of Helm charts without Helm running locally. That's kind of cool. Not the biggest one.
If you've invested heavily in Helm and you're moving toward an operator model, then you could just quote wrap it up as you were saying earlier in an operator, and it would just do the heavy lifting.
That's a good way of putting it. Heavy lifting. I would consider it heavy because the probably biggest benefits is, I would say, the use of definitely an advantage is to be able to have the use of the custom resource definitions. So I'm not saying I'm doing a Helm chart and exposing to my end users, here are all of the different kind of guts. And even if they don't look at the chart, it's still there. This time they're saying, look, I want you to interact with a visitor's object. And you saw me edit the visitor's object through the kube edit command, or I could just use edit the manifest directly and then reapply it. So I get this interface of using these custom resources to actually interact through the Kube APIs. And again, you saw me doing Kube get visitors because I'm able to ask Kubernetes, tell me about your visitors, or tell me about this particular custom resources. And then again, depending on operator. Okay, good. So let's keep going with these questions. Work to make the operators have life cycles interact with each other. Helm install my database. The operator runs. Yes, that's actually a good transition to the next benefit. So earlier I was talking about operator lifecycle manager, OLM for short. And it is it does for operators what DNF does for RPMs, where it handles dependency management, it handles installation, it handles understanding channels and upgrade paths and things like that. So I could have defined, okay, this is great. Let's run with this. I could have said my visitors operator relies on a custom resource definition called MySQL database. And if I had done this through OLM, OLM would then have looked around and said, okay, there is a dependency on a resource type called MySQL database. Let me see if I have an operator that can support that. And it looks around its sources and it says, cool, this operator handles MySQL databases. Again, the custom resource type called MySQL database. I'm going to install that operator first, get it running. So that way, when the visitors operator says, create me a new MySQL database, that gets answered. And Kubernetes can actually answer that question. So yes, my example embeds MySQL into here. A cooler, cleaner, neater example would be if we had a separate operator for MySQL databases that the visitors one relied on. And that reliance and that dependency management comes through OLM. Your question. Awesome. Yes, Frank, I kind of really dig that too.
I think that's one of the really big things too, right? Like if I have some software that's dependent on other things, one of the properties of operators is being able to have dependencies on other operators. So I could say that I rely on the Postgres SQL database and I need to pull that in, but I didn't write that. I don't care. I just know that Postgres or CrunchyDB or whatever is available in the operator hub. I could reference that, pull that off the shelf, and there we go. All a part of Operator Hub and using the LLM, which is really valuable. And if the Helm chart for the software that I'm trying to do isn't written in an operator, I can't use that dependency matching. That has to be wrapped in an operator to be able to do that. And that's something that you get valuable out of it.
It's interesting that there's not a Postgres official operator, or am I just not? Yeah, right. Is that common? Is that common that you don't get operators from well, Percona makes a lot of money off of MySQL.
Yeah, and I think that's what it boils down to, is the people who have invested the resources.
Certain vendors, certain upstreams have things on here. So there's stuff like that. If you look, so within, speaking of OpenShift, in OpenShift, there is a version of the Operator Hub that has stuff like that database.
Hey, Brian, I don't know about you, but I love running 002 current for my production environment. So I'm going to run that.
Yeah, the version.
That wasn't giving me a lot of confidence. That's not giving me a lot of confidence.
Very early state. But yeah, I mean, they're currently at that stage, right? They're working on it.
Yeah, no, I probably shouldn't say this on stream. Yes, it has been, I think I said earlier, minimally vetted or mildly curated. This is that kind of push on it where look, you still have to do due diligence. This isn't, okay, so I don't want to turn this into a Red Hat sales pitch, but ultimately this is not the same as Red Hat certified. We have our certification teams that are doing much more rigid verifications than this. I keep going to call this an upstream site, where it's a little buyer beware. What we've asserted is that how far it goes, and it's not going to do anything particularly broken or malicious. I'm curious to see how much. I used to be on the team that reviewed these, and this was like a year ago, so I'm sure it's changed drastically. But I'm very curious to see how much due diligence is put into verifying the permissions granted by these operators. So it's there. We might be able to look, although I don't know that I want to know the answer. Roll.
That's a lot of permissions.
That's a lot. I mean, you know, arguably, you know, a database is going to need PVCs. It's going to need to create its own secrets. There might have been ways to trim this down. This is looking pretty much like the default one, though. And off the top of my head, I'm not completely sure what we could have pruned because I can see a fair amount of this being used by
database is going to need to deploy a pod, a service. It needs to like say, hey, I got a finalizer before I could close out this project or whatever. So like those things, I think.
It doesn't look particularly heinous. It's a little disconcerting that it looks so much like the default one that you wonder if he said, hey, this all needs to be there, or just I didn't know to look for it. So there is still some due diligence. The flip side is you see that alpha, and if you install that, you better know what's going to happen at that point.
Yeah. I mean, like Babe Cafe said, alpha in Kubernetes is good enough for production, right?
It's too close to home, man. It's too close to home.
Now, okay, something to mention, though. What were we just looking at there? Was that Maria?
Yeah.
MariaDB, yeah.
I don't know if it's flagged on here or not, but I know in the OpenShift UI, when you install an operator through the operator hub, the OLM stuff, you say if you're going to install it cluster-wide or namespace, or just in a single namespace. So that's a configurable option. Generally speaking, you should make it namespace unless you have a need to do it cluster-wide. You may need it cluster-wide if you're doing cluster-wide stuff. So all of OpenShift 4 is architected on top of operators at this point. So the node management, network management, all of that kind of shit is done through operators. Yeah, those need to sit at the cluster level.
Okay.
I mention all that because if this is installed in a particular namespace, then that security stuff gets even a little bit more understandable because you've only scoped it to that namespace anyway. So being able to delete pods if you don't install this cluster wide, you know, it's not quite as malicious as it could be.
Got it.
Okay. Okay, so Helm. So we've run the command. We said download this archive and actually include that as the Helm chart. So if you remember, we've done a single command at this point. We go under the Helm charts.
We install Tiller. No, I'm kidding. I'm kidding.
Somehow that's the most offensive thing you've said on the stream so far. This is the guy who mentioned COBOL for 3 straight weeks.
Hey! I'm maybe I'm just not 100% today. It's been a long day already. Maybe I'm just not 100%. And also, I'm really trying to learn this stuff too. So you know, I can't be on my
can't be on
trolling
top
side.
Of the game. Yeah, you got
exactly.
Pay attention.
Exactly.
So when I dig into the templates, you'll see what you're kind of expecting to see at this point. So the back-end pieces, the front-end pieces, the MySQL pieces, again, automatically dropped in place. So I don't even need to do my cool new tagging solution, although I'm probably going to for when I manually build this. But we've built it from directly from the archive that's uploaded someplace. And again, at that point, you can tie it into your CI/CD system as necessary. So if that's already producing an archive version of your Helm chart, then you just pull in the latest version there. You're not recreating an installer or anything like that. So I want to delete the old CRD, even though I think they're going to be named the same. So that was from the Ansible one. So again, we're going to run this outside in an outside process because it is faster and simpler and easier to iterate on than trying to build an image every time. So we deploy the CRD, and that's cool. And again, I did that step just for cleanliness. Presumably, I should have cleaned up my cluster better between the 2 runs, but come with me. And then I'm going to do, I think it's the exact same command. So we're going to run it. We're going to say local. We're going to give it a watches file. And if I remember correctly, the Helm one runs correctly with the default or the production level watches. It's able to use relative paths correctly, where the Ansible one wants the full one. Yeah, so it's even cooler. It makes that example. And the way I plan on doing this when I typically teach it is I go from Helm to Ansible to Go. So this will actually been kind of the first thing most people see, but we'll see how it goes from there. We'll set up our watch again because this should go a lot faster because the images are already downloaded.
Mm-hmm.
Go to deploy. And then we're also pushing the maximum of what the CSS may handle. So this may look like dog shit, but that's okay. All right. So this is cool because we get to see very quickly before it goes off the screen, the actual visitor's resource getting created at the bottom. Instead of all, I may just start running pods and services. I don't really care about replica sets in this example. And it's up already. At the time I was thinking to myself, everything has stood up. So we have our SQL database, our backend, our front end. And if we go back, oh shit, what was my Minikube I pinged?
Yay.
And we have the Helm-based version of it, still getting refreshed every time I bounce it, or every time I hit refresh. Okay, so same thing accomplished, two wildly different technologies, neither of which, I mean, I technically have Ansible installed, but neither of which I had to install locally. I should also mention, I'll mention this when we get to the Go part, never mind. So to summarize, because this is probably a good time for a break before we dive into the Go one. We've ultimately not
Can we do one in Lisp instead?
You know, I actually don't hate that as a response. I had this like period where I went like how like teenage kids go through like a goth period or whatever. In my like mid-20s, I went through this period of closure, which is basically Lisp on the JVM.
Yeah.
So that one I don't hate too. I was just like, yeah, I'm gonna be that obnoxious guy that uses closure. We had a QA guy who did that. It was one guy, he loved the language, and he wrote all this automation. And then like 6 months later, we're like, God, we hate this guy right now because nobody wants to or knows how to write it.
It's so true.
Yeah, so let's quickly summarize things. Both of the two examples we use, so building off of existing technologies for whatever reason. One thing I hadn't covered yet is we have Ansible and we have Helm engineers in-house. We don't have a Go programmer, but I want to use operators. Cool, we got you covered. Or we're already existing Ansible shop that we've put a whole bunch into, and we don't want to reinvent our installer because of this. Also totally viable. So using this SDK, which again is one possible way to create an operator, it's not the only one. It's not even necessarily the best one or the de facto one per se. It is just an option that if you have either of these technologies, you build the scaffold and you bring those charts or those playbooks in, either at the build time for the project or at a later point. And then it's on you at that point to figure out if you want to pull from some sort of archive that's been through CI/CD, or if you check it out from Git, which was a fun little tangent we went on. Regardless, I get the playbook or the chart in place. I deploy the CRD, which is very important because if I'm going to talk in these very specific applications terms to Kube, I need to teach Kube about them. I start the operator. So for both of these, and we're going to see with the Go as well, I can run them as this process outside of the cluster. That's not how I would do it in production, but for development purposes, for that inner loop of test, write, test, fix, I would just kind of keep bouncing that service and keep deleting it. It actually goes significantly faster than the image. And then I just start deploying resources. And you can see the operator logs as they kick in and start doing all of our necessary steps in the middle. I absolutely could use a break right now. And this is 4:00. This is about a good time before we dig into the Go stuff, because it's a little more involved, which gets you more of the flexibility at the same time. So does that work for you guys for a break?
Yeah, works for me. All right, well, go ahead and give us five-ish minutes, and then we'll be back. I want to say hello, and we're in our third hour now, 3 hour something. Well, second hour going to the third, but it's really the third. Anyway, whatever. I don't know. You get the point. Hi, I'm JJ. Thanks for sticking around for the third part of this stream. I'm here with Brian and Jay. Brian, you want to say hi?
Hey, how's it going, guys? So I'm Brian Tannous. I am a developer advocate focused on OpenShift and Red Hat.
And Jay, you want to say hi?
Yeah, my name is Jason Dobies. I'm the same team as Brian, so also a developer advocate for OpenShift. And yeah, like JJ said about where we are in terms of, why does it say hello? What's your name?
Yeah, I clicked the wrong button. My bad.
Yeah, you can tell where we are in the stream. We're all getting kind of punchy at this point. We're like, when is it now? It's still Friday. Okay. So we have been talking about all things operators. We've been building them, actually. This is much more developer-centric. We started out by installing one off of operatorhub.io, but we really dug into some of the tools. And I'm going to reiterate what I've said a couple times now. These are just some of the tools. They're being donated to CNCF, so they originated at Red Hat, but it's not the only way. So the fact that they support, as of right now, Go, Helm, and Ansible doesn't mean those are the only ways to write operators, doesn't mean it's the best ways. I'm not a fan of Go as a programming language, which you're going to notice in a couple minutes as you see me stumble through the syntax. There are Python projects out there. I'm pretty sure there's a Java one, and there's probably more than just that. Because at the end of the day, we're just reusing existing Kubernetes constructs in a particular paradigm. And that's, very good to continually reiterate, because a lot of our messaging and how we talk about operators tends to give them a little bit of a black magic feel. And that's not to take down the benefits of them, because there are definitely a lot of reasons why you would want to use one. There are some very cool things being done with it, like internal to OpenShift for itself is doing a ton. So much of it's architected around them. But at the end of the day, it's much more of a paradigm than it necessarily is a separate library or just living in the SDK or anything like that. So we've poked around a bit and done some examples on this visitors app. So it's a simple 3-tier application of a front end in Node.js that gives us a web page, and every time you refresh it, it's going to send a message to the back end and say, hey, we have a new visitor, and that's going to snap it out to the MySQL database and say, hey, this is the log of them all. The application itself isn't that interesting, but it shows how we're going to go about using an operator for something a little more interesting than just deploying a single pod. We have a internal workshop that I don't particularly like, because it just does a pod set, which is basically just a group of pods, and it confuses people even further because it doesn't show kind of why you would do this, because it's basic Kubernetes functionality. So so we are doing this visitors application. We've done it in Helm and Ansible so far, which has basically been take the existing technology, so a chart or a playbook, stuff them into an operator, which is a fairly simple process, and then run the operator, and it reacts to the custom resources, runs the underlying tech, and ta-da, application. Now we're going to dig into the Go operator, which is what you would expect when you start to move into a full-blown programming language, in the sense that it's more powerful. It's also going to be more wordy. It's going to take us a little more to get going. And this demo doesn't go to the points of really showing a lot of the power, like any of this kind of super long day 2 operations. It's just not there yet. But I need to get it to that point. So the first thing you'll notice, if you've been watching from the previous part, is that we're now working inside my Go directory. This is just a particular Go construct. We've got to have our source code in the Go path, so it's actually going to run. I'm going to say I want a new
Can't see your terminal.
Oh, shit, terminal. I'm not sharing.
Amateur hour, man. Come on now.
Tell you, man, it's that going into that third-ish hour, everything gets a little fuzzy. All right. Seeing terminal now?
Yep.
All right, so you didn't miss much. I'm in my Go path. This time the command was a little bit simpler. I simply said I want a new operator defaulting to Go, so I didn't have to say type is Go or anything like that. It generates kind of what you'd expect. Some of this stuff is going to look familiar if you've been watching from earlier. So we have our deploy directory. And if we look inside of that, we have the things that run the operator itself. So our service account and role, and then the operator. We don't have a CRDs directory yet because we haven't told the SDK, hey, we're adding a new type or we're adding a new kind yet. That's an explicit step in the Go operator. There's probably a better rationale for this than I'm going to give, but I know it makes things very nice when you're adding multiple resource types. So if we think about the Kafka operator from what feels like 3 days ago now, it defined a number of them. I didn't focus too heavily on the amount, but we saw at least 2. We saw the Kafka cluster itself and the topic. There's actually upwards of probably 9 or 10 more on top of that. I've seen MySQL operators that will deploy not just the ability to create a MySQL database, but then also have a resource for a backup and a restore operations. And as I say that, I want to say it might be Couchbase instead of MySQL, but
like
database.
Service mesh operator, you go and install and it'll set up a service mesh control plane, which requires Istio, Citadel, it requires Elasticsearch, it requires Jaeger. Like these things are other things that it pulls in too, right? So those are valuable things that are needed. And that's an example of one using multiple dependencies.
So next step, we are going to add an API, which is effectively saying we want to add the custom resource definition. Now, I haven't leaned that heavily in today in really equating custom resource definitions to APIs, but in a lot of the messaging, that's typically how I do it. We're defining a way to talk about our application to Kubernetes, and arguably that's an API. So using this visitor's resource that is our API into our particular application, and it's the operator that's interpreting it. So you'll see it created this this CRDs directory under deploy, and that's going to look very similar to what we saw earlier. It's going to have the custom resource definition itself, and then an example custom resource. It generated some Go code for us. We're going to take a look at a little bit of that in a second. And then as a personal note, I need to make sure I have typed all this correctly because of the way Go handles imports. And it looks like I did. So let's go into deploy. And I just want to show it because this version makes it a little more clear that there is a spec and status section. So spec, this is what I can pass into the custom resource when I create it. Right now, this is defined as simply object. So going back to earlier, I can pass in foo equals bar, and the operator will get that data and then just do nothing with it. Status is kind of the opposite. Status is the operator's ability to add values into the custom resource that describe its state. So we know how we're going to configure our visitor site. We're going to give it a title and the number of backend instances to create. In this case, the status is simply going to tell us the exact image that was used for both the front end and the back end. Not terribly useful, but for demonstration purposes, it's kind of showing you that it's the operator's way of telling me back as the user, hey, this is some info on how I set it up. Because you'll notice we're creating a visitor's resource. We're not specifying image names or anything like that. That's all handled by the operator. I don't know if it comes from Quay. I don't know if it comes from Docker. I don't know what's going on there. Don't really care. From an API standpoint, give me my visitor's resource. Mm-hmm. Okay, so let's get to some actual code. Nope. So I need to figure out how I'm going to walk people through this who don't really know Go. But this is a types file. So this is going to be the internal structs that the operator is going to use for interacting with these spec and status fields that I just described. Mm-hmm. So instead of putting this information in the CRD, we're going to start by putting it into this file. Because again, the code's actually going to need it. So y'all can sit there and watch me type for a second until I figure out a better way of doing this.
Copy pasta, my friend.
I might end up doing that. I have some of this copy pasted. Here, I'll just show you what I do have. I was going to try to freehand it, but as I'm doing this now, it's just going to be ugly.
There's no shame in copy pasta, especially when you're bringing in code like this. But that's a great way of having those dots there. That's so you type out saying what you're doing right here. So it's an opportunity for you to walk through each of them and also make sure you don't forget something.
I like that. That actually, it's funny because I was going to say the reason I didn't do it is because I had dots. We're going to see in a second that these comments get pulled into the CRD when it's created. So the dots were my own personal notes. Remember, hey, stupid, go back and fix this. But actually, I may just leave it that way and talk over the fact that I'm just adding in some extra information.
It's a very natural way of being, and also, it's a very natural way to do it.
Oops, that's a bit too much. And then we'll copy in the backend information, and I'll describe to you what that's doing. So it's this code. If you're not familiar with Go, we've just defined basically two object types. The spec, as we saw in the earlier example, is going to have a size and a title. And then the status is going to tell us this is the backend and the front end image that we're using. Those are tabs. Okay. The front end and back end image that were actually deployed as part of it. And the rest of this information is just some extra stuff. I mean, obviously these are the Go types, and then this is a little bit of serialization info. So I want to point out, I added comments above the two. That is not just me as a good disciplined coder. It is also used in the CRD itself and the validation. JJ, you of all people, I imagine I saw you nod there. I imagine you're probably really good about it, and it makes me very happy. I was talking about my students earlier. That's one of the things I'm like super strict on. Like, you guys just start now. At least let me know that you've passed me and you know how to write a friggin' comment in your code.
Exactly.
Don't be one of those people who don't need it.
It's one of those habits that I wish I had when I first started. Like, I remember back in the day, one of my first teachers taught me how to make flowcharts. Like, why would you ever need one of those things? What do I do nowadays? I'm thinking in flowcharts, right? I don't draw them out, but they're still valid, right? Like the writing out logic to understand how to get something done is a muscle memory you have to have. And comments are a great way to create that flowchart inside of a file to know why you're doing something the way you're doing it. Because in 6 months' time, you're not going to fucking know.
Yeah. And you just said the exact thing. I'm like, I don't need the comments to tell me what it's doing, that I can read. I need to know why. And I'm trying to explain all the times where there's been that code. Everybody's hit this code where, like, if you swap two lines that look like it shouldn't do anything, but it goes from working to crash and burn, everybody's hit that in a project. And you have that comment like, don't move this. We don't know why, but nobody touches it and everything keeps working.
Exactly.
That's the exact thing. Like, the people who say
never fix.
Code, yes, exactly. People who are like, my code documents itself. Like, look, documents what it does, but I want to know why. Like, did you try another approach? Is there a particular reason this looks weird? Exactly. All right. So once you change the types, we have to do this generate Kubernetes or KS. That's just simply refreshing the code based on the fact that we changed the types. This one's much more interesting. This is going to update the CRDs with the custom resource definition, with that type information and that variable information we just added to the visitors types itself. So easiest way to see that is to actually open it up. Strong file. We saw earlier spec was this empty type equals object. Now it's a lot more fleshed out. And you'll notice that it has size and title as its allowed properties. It took its description out of the code, which I actually really, really love, because now I kind of never need to think about my CRD. And if I'm a good programmer who wrote that stuff in, then it just kind of gets pulled up for free. I'm always kind of a sucker for when, like, API doc generation is able to do that kind of thing as well. That always makes me super happy. I didn't go into detail, but this was actually the comment on the struct itself, so it pulls that in too. Point being,
one line.
What's that?
Can it only be one line?
That's a great question. I only discovered this happened like 2 days ago, so I haven't tried these kind of dorking around with
Slacker, Jay. Slacker.
Hang on. Now, you know what? You've got me curious.
Might as well just go add another comment.
Now's the time to do it. Yeah.
Exactly. Let's all learn together.
My computer reboots. Oh, no, that was bases.
Yay.
And then let's throw something up here.
This is a very descriptive description. Just saying.
Listen, this is why people don't write docs, because they analyze this type of shit. Just it's a good practice. Run with it.
There you go.
So we rerun the deep copy stuff, and then we'll run the it should autocomplete. What did we get?
It concatenated it.
Just added it together. But that's still nice.
Yep. That's arguably that's how I would want it to be, because if you on a project that's still using an 80 character width, I'm likely going to have split sentences anyway, whereas the YAML doesn't appear to have that issue. And it's funny though that it's breaking here. I'm guessing they've got their own linting going on. That what is that?
Whole words only so many characters.
Yeah, maybe they did something. I mean, this is obviously just shots all help, but it's a URL, so it's treating that as one word. Wait, but whatever the case, it didn't split it where I split it, which is kind of
don't you need the pipe at the end of description to break it like that? Or
I would
in
think
YAML?
so. I think so. Let's see what happens when we try to.
So bring up the YAML spec. Let's
read.
We're going to go a little more ghetto in this. We're just going to try to use it.
Try to use it. Paste it into a YAML linting website.
There you go.
Created it. And if we take a look through it.
Yeah, looks fine.
Yeah, it looks okay. And yeah, it looks like it. Renders them together too. Yeah, it looks fine.
Cool. Today I learned.
Yeah, surprising.
All right, where the hell was I in my demo? Okay, so we've fleshed out our custom resource definition. Basically, we've said here are our inputs and our outputs for the visitors. Nothing's going to happen yet. We still haven't added the controller piece. Now, we didn't have to do this with Ansible and Helm because that's effectively hard-coded. That controller piece understands how to apply the watches file and call Ansible or call Helm as appropriate. Here, we do need to have an actual Kubernetes controller because we're just using full-blown code. So we're going to do, instead of add API, I don't know why it keeps doing that. I'm going to say add controller. Again, we're saying I want to add a controller for this particular type, which is why I did the reverse search. It's just a lot simpler. It's the same thing as the API. And we'll notice that it gave us this controller.go. I haven't really spent a ton of time talking about this, but if we look at all of the Go files, there's others that we're not messing with. We just don't really need to. The dcopy, obviously, it's generated. We're not going to want to mess with that. That's what that generate K8s command is doing. Thankfully, for all of the code we're going to see, there's not that much we need to manually dork with. So if we go under package, controller, visitors, and again, here's where from a presentation standpoint, I need to figure out a better way of doing this because there's definitely some copy pasta going on here.
So it seems very, very boilerplating.
Actually, let's try this. Because I was thinking I might pull up VS Code for this just because I think it'll go a little bit easier. We'll at least get better syntax highlighting. So the big thing in this method, in this, oh shit, what are they called? We'll just call it a file, is this reconcile method. Okay. And I haven't really focused on this a lot yet because this is all taken care of for us in the Ansible and the Helm world. But reconcile is called every time a resource changes. So if a resource is created or a resource has its configuration updated, or even if a resource is deleted, it's going to call this reconcile method. You'll notice there's no resource added event. There's no resource deleted event. This reconcile is consistent with the Kubernetes mentality of it being declarative. In other words, here is the new state of this visitor, make it so. So this ends up having to be a fairly beefy, complicated-ish method. This has to be able to account for creating new visitors, but it also needs to be, I was about to say super idempotent, which is kind of pointless comment, but like really has to be idempotent, because if I were to call this in every reconcile, it's just going to dump down new pods. It's going to get out of control real quick if it treats every reconcile as an add instead of doing, is there ready pods existing and so on. We'll come back to that in a second. For now, let's take a look at these watches. So remember that when we ran earlier the example of we created the definition, we created the custom resource, and then nothing happened because we didn't have the operator running. That's because there were no controllers watching that operator, or I'm sorry, that custom resource type. So what happens at the beginning of the Go-based operator is it sets up a watch for the visitor's resource. Anytime a new visitor's resource is created or has some kind of event that happens on it, this controller is going to get notified and reconcile is going to be called. That makes sense to leave in place. This next part is then saying, and this is just scaffolded code. This isn't saying this has to exist this way, but whenever a pod changes, if its owner, and I was confusing the term owner and parent before, if its owner is a visitor, I also care about that, because that means one of my child resources that I've created by this operator has changed, and I probably need to care about that. If this pod got deleted, it's this operator's job to say, all right, well, based on the visitor's definition, I need to recreate this pod. Maybe I don't need to create this pod. Maybe it was a simple one-off backup operation that was running, or maybe we had some spares floating around for pooling purposes that, you know, due to thresholds for whatever reason, we can let die. We have that ability in Reconcile. We just need to be notified when these events occur. Thankfully, we're all familiar-ish enough with this application to know that we have really two things in play here. We have a deployment and we have the services. So we're going to add these. Instead of listening to pods, we're going to care more about the deployments. And then we're going to care about services. Did I type that right? Apps v1.
So I guess how do you know that, hey, like this is core v1.service or .pod or apps v1.deploy? Like how do you know what those are?
Yeah, so this all goes to the API docs, which are actually not awful. KAS, oh, API, cool. So this just took some looking around. In fact, we're going to see, this is probably good to leave this up because we're going to really dig into this in a minute, but let's take a look at core for a second, and we want to mess with services.
Just 1,000 matches. It's fine.
Yeah, seriously, I screwed that up. Type service.
There we go. You'll get there eventually.
I'll get there eventually. So this defines all of that, the K8S package in Go. And this becomes handy because you're going to see we're going to create an actual service object that we're going to hand back to the client and say, create this guy. So you'll spend a lot of time in here understanding, okay, I need to create a service spec for it. What's in a service spec? Service ports, selectors, and so on. Well, what's in a service port? And then you end up going down this tab tree from hell, which I can't think of a better way of doing it. I can just be kind of grumpy and say this is very annoying to deal with, but I see why they did it that way. These are all just nested objects.
I mean, yeah, you're gonna, because you could pretty much deploy anything that's available. Like, you know, you could create another operator that's deploying like these visitors or whatever. So like, I could see why like it needs to be extensible. But like the thing is, whenever you're using the Ansible one, like the Ansible operator, you're still probably gonna go look up, like go to Ansible Galaxy and look up the Kubernetes, you know, stuff. So you can pull that in and see what's available using their docs or whatever. So like, I think it's similar. You're doing the same thing, right? It just depends on which one you chose.
Yeah, you're totally right. And
like might be easier in YAML versus Go, but
It's the same thing. No, you're absolutely right. I mean, in the Ansible, which we didn't look too closely into, it's using the K8s Ansible modules. And if you're not intimately familiar with them or you're new to using them, you're going to have to do the exact same thing, like, which I had to do because it's very infrequent that I end up working with that stuff. So I was like, shit, I don't remember any of it.
Yeah.
So I need to figure out the clean way of transitioning to this, but okay, so we're going to watch in deployments. We're going to watch in services. That's step number one. We got to make sure we set up those watches. Now, step number two is going to be implementing the reconcile method. But before we get there, I copied over a couple of utility files, basically the actual guts of what we're creating, because there's no Helm retyping all of this. So let's take a look at, and this is Brian, this is what you were just asking about. To create the deployment resource in Kubernetes for just MySQL ends up being all of this. The structure will look similar. So there's the metadata section, there's the deployment spec, which then has a pod template stack, which has a pod spec, containers, images, environment variables, all of the things you would see in the manifest for this, just done as Go code.
Yeah, standard deployment using Go scaffolding or, whatever. Yeah.
Exactly. So we're just using the Go objects for this. It just ends up looking, a little more convoluted than YAML would look, but at the end of the day, it's in code references. But this goes to your question, like, how do you know? When I was writing this, I would just go to that page, search for what I was trying to create, and then figure out kind of backwards from there which module it fell under. Now, to be fair, though, those modules do correspond to the API versions that these live in. Where can I go?
I mean, there's probably also like a Go module that you could add that like takes in YAML as these structures or what, like
a parser. Yeah, just hard coded in. I'm sure there is. Now we're getting into, let's acknowledge the fact that this is a full-blown programming language. So how you do this is going to vary spectacularly from operator to operator. This is my choice for simplicity. Yeah. And also because I'm not a native Go developer. So, I didn't have all of the creative weird tricks I could have done if I was in like Python or something like that. Why was I over here? Doesn't matter. Okay, so in each of these backend, front end, and MySQL, I just have methods like this that say, please tell me you're still working. I gotta fix that. Hang on. Oh no, it is visitors.
Yeah, so like just speaking of, like there definitely are multiple Go like marshallers and demarshallers that could like take in Go and put it into a structure that, or take in YAML that could put it into a structure that Go can understand. So you probably could work with that, still using other deployments and things like that if you're used to YAML. But exactly your point, it doesn't matter. It's a programming language. Like you work with it however you would work with it in other aspects. Just because this is using the operator SDK doesn't mean that you have to do something a certain way. But like there are like the reconcile and things like that are important that you want to have.
Shit. So ran into a minor hiccup, and it's just the fact that I haven't really smoothed out this presentation yet. So in the sample code that I copied over, I had called it visitors app. In the one we did just now, I called it visitors. So Brian, keep talking about shit while I just clean all this up. Vamp, Brian. You want to talk more about what the operators are internally doing in Red Hat and OpenShift?
Find and replace all, but that is true. Yeah. Okay. So like one of the big things with OpenShift 4 is the difference that all of the services within the OpenShift cluster now are managed with operators, because why wouldn't they be? They need to be operators. The whole point of them is to be able to define what we want to run in YAML or any kind of configuration file, JSON, whatever, and be able to run that stuff and define it however we would like, and have the operator act upon that and run and manage those things that make sense. So with OpenShift 4, one of the big transitions was all of the services that are running the OpenShift Kubernetes cluster are managed by operators. So the API server, the thing that is handling the operator, so the OLM has an operator that's being managed, or that's managing OLM to make it work. There also is the concept of the machine set and machines. So there are namespaces that are part of the or part of OpenShift. When you install, you could look into them, OpenShift/machine API or what have you. There's a couple of them. And in there, you could see there is an operator that's managing the ability to add nodes and remove nodes, like physical machines and worker nodes and master nodes into our OpenShift cluster. So all of that stuff is being handled all the way down to like the physical machine, right? Kubernetes is managing that. So what that gives you is when you're deployed in IBM Cloud, or you're deployed in GCP or AWS, or you're using something called Metal Cubed. We talked about this at Summit a little bit on a bare metal type instance. The operator could go talk to the respective cloud's API. If we're using OpenStack, it'll talk to that, or VMware, or whatever. Like, there are ways that the operator can manage installing OpenShift for you on that cloud provider. And it will go through and go and provision more operators that manage other things. One of the commands that you could run whenever you're done with this would be OC get CO, so the cluster operators. And
this is Minikube, it won't be there.
Oh yeah, you're on Minikube. Maybe, I don't know if I have access to it really easily.
Well, it's here. You look that up now that I'm actually in place. You can stop vamping for me.
Yeah, that's all good. I should have access to it, and I'll show you later, but that gives you the list of all the operators that are there, the OAuth, all the stuff I talked about, monitoring, logging. All of those are managed by independent operators that are upgraded independently in the OLM, so that stuff gets upgraded the way that it should and managed the way that it should. And it tells you the status and stuff like that. So when you're doing an upgrade, that's where you would look to upgrade versions of OpenShift, and you see each operator getting upgraded independently, and then it goes and upgrades the nodes and all that stuff. So it's really cool to see the upgrade happen and those operators do its thing for the infrastructure. And the point of operators is it's managing the lifecycle of that app. It's making sure the upgrades happen whenever I'm still using it, so it doesn't disable the API service for OpenShift, for example, or Kubernetes. It upgrades in place and it works fine.
Okay, so I think I'm all cleaned up. We'll see how this actually plays out. I might have missed a package or two. But to quickly summarize, so backend, front end of MySQL, all these do is define the Go representations of the pieces we're going to build. So we have a secret for MySQL, the deployment, the service. I'm going to specifically point out, just because I want to watch JJ have a bit of a seizure, that the operator has hard-coded the MySQL password, which
that is a little weird.
Yeah, I could. It should be generated. I just didn't. But so every single visitor's app deployed by this operator will have the database username and password hard-coded in. Maybe I'll fix that before this presentation in 2 weeks. But
you should put Hunter2 down for the password.
I should just
see if anyone catches that. That'd be good.
I would normally just kind of glance over it. But I pointed out just because I know you love picking up on this shit. Because if I didn't, you were going to call me out on it. So
I was. Yeah.
Ownership.
You're right.
So these are building up the resources that we're going to create. And again, since this is in code, though, I could easily generate this to whatever I wanted it to be. And that's one of the neat benefits of Go, is I could have my cool password generation algorithms and all that kind of weird shit. So no need to go through that line by line. I do want to point out these common set of functionalities. I have, again, this is my approach to it. Probably not even how I would do it again. This was the first pass, and like, this makes sense. But I have this concept of ensure the deployment, which is basically create if it doesn't exist. If it does exist, you're fine. So you'll see code in here that tries to retrieve the deployment itself, If it's not found, we go through the steps of actually calling into the client. So inside of this reconcile method, we're given an authenticated client against kube that we can do, create and update and all that. Goes all the way back to 2 hours ago. We first started talking about RBAC. This is why those need to be at least in place. And you'll notice if you try to deploy an operator and you didn't set that up, stuff like this is going to fail because you're not allowed to do shit if you're not allowed to do it. So another thing that's worth pointing out is the return value. So you're going to return, and this is, I friggin' hate Go, but you can return this reconcile result and then like all Go code, this possible error, and it handles things a little bit differently. So let me look, actually we'll look in visitors controller. So I have these ensure methods, which let me know if you want to go back and talk through them more, but effectively this just says, make sure the secret's there, if not create it. Same thing for deployment, same thing for the service. Now to make life a little bit interesting, we're gonna have a check to make sure MySQL has come up before we do anything else, but it's not gonna block. So this isn't something that is gonna have any kind of blocking operation that loops and sleeps for 30 seconds or something like that. It's going to immediately check. And if MySQL isn't running, we're going to wait 5 seconds. And then let me explain this differently. We're going to return the result. So this reconcile immediately ends, but we're going to tell Kube, I want you to requeue another reconcile request for me just after a delay. And right now the delay is 5 seconds. So instead of blocking, waiting for MySQL to come up, which could be fairly instant if I have the image, could be 15, 30, 45 seconds, however long, depending on my network connection, we're not going to block and hold up resources. We're going to tell Kube, all right, I want you to go back and give us another reconcile request. Just wait X amount of time. And that's one option. Another option for returning is simply a result. Hey, reconcile returned successfully, we're done. And then a third option, and depends on how you organize your variables, is an error situation. In which case Kube will figure out how it wants to handle it. And errors happen. So we see if MySQL's running. If it's not, we end the reconcile and we say, Kube, come back to us in a couple seconds and tell us to try again. And you'll see, we probably won't be able to see it in this example because the images are downloaded, but you'll see the request come in and then it pauses for a little bit, the request comes in. So we're letting the Kube resource management do its thing, and we just run through this reconcile method. And then again, we just go on to the back end. So ensure the deployments. The other piece, remember that reconcile is the sole input. So it's not just called for things like creation, which is largely what this flow has been doing, but it's also called for updates. So every time this reconcile comes in, not only should we see are my pods running as expected, but has any configuration changed? So I have a specific call for handling the back end and handling the front end methods. I'm sorry, I pointed to the wrong area. So if, for instance, I change the size from one backend instance to 2, this method is going to take a look and say, okay, I know which variables I care about. I care about size. I don't give a shit about the title. So I'm going to get the size out. I'm going to compare it to what's actually live, and then I'm going to resolve the differences, which is exactly how Kube runs across the board. I don't manually create a new pod. I tell Kube, I want you to have 3 replicas. You figure it out, make it happen. So we're honoring that declarative interface, and it's just enforced through the API that we only have this reconcile. The one I skipped is updating the backend status. So remember how I said that we are going to take the image information and shove it into the resource itself, and that's going to go back, and when we view the resource, it's going to give us both the spec that we specified, which you've seen before in a pod or any other resource, but a status. So any information the operator has injected into it. Do the same for front end. If everything works fine, we simply say, cool, we're done. Here's your result. We're not requeuing it. Life goes on. Now, assuming I've typed all of that correctly, which I'm not 100% confident with right now, but let's see what happens.
Let's see.
We should be able to run this.
I feel like you got it first try.
I appreciate your optimism. But then, I mean, you're a developer too. So if I get it in the first try, I'm going to think I did something wrong. It's like when your test pass in the first try. You're like, that doesn't feel right.
Nope.
So my custom resource definition is out there. Again, my operator wouldn't start without it because it actually needs to know, to be able to bind to it. We actually saw the watches. So if I try to set up a watch on this visitors type and it doesn't have it, it's going to completely crash. Let me double check my notes here. I think it's just run local. Screw it, let's just try it.
Ooh.
Which one did I miss? Go build.
Do you need to go format the thing?
So this is the typo issue. I see.
That's a Go thing, right? Go format.
Yeah, dude, don't. I hate Go so very much. Well, why is it talking about log redefine? Oh, I know why. Okay. It's the order in which I pasted this in. VS Code is actually kind of cool that it's doing a lot of auto imports for me, which I noticed while you guys were talking about something else as I was dorking with all that stuff. It saved me because I'm like, why didn't I have to manually type this in? The problem is when I go out of order and I pulled in files in the wrong order that it tried to do the imports. Okay, that's not bad, but really, really good to know for when I do this in 2 weeks that I need to clean that whole stupid process up. But easy enough to recover from. So we have our controller running. We'll give it a little bit of space to breathe.
It just added like an import that like wasn't.
It shouldn't have been in that file.
It shouldn't have been.
Yeah, it was already imported in another file, but it wasn't yet because I hadn't copied over that code yet. And
yeah, trying to be smarter than it should, but it's fine. It's okay.
Yeah. Visitors, is that what I called it? Okay. So we have our operator running at the top. We have our watch in the middle our kubectl watch in the middle to show us what's happening in the system. Let's go to the right directory. And thankfully, the time I'm presenting this, the Go is an entirely separate, let's say lecture course. So I won't have to do a lot of the swapping around. I'll be in the right directories ahead of time. Oh, you know what I should do? You know what? Let's not do that. Okay. So this is the default custom resource that was created. This looks identical to the other ones from before. So example visitors and size is 3. I'm not going to change it though. And I'm just going to try to add it right here. And we see Kubernetes immediately pitches it back to us saying spec.title is required. So back to half an hour ago when I implemented that types file and I ran that generate CRDs, that gave us that open API validation. So now I've given my API some real meat to it, that it's not just giving users the ability to say, create me visitors. It's also giving me the ability to tell users, this is how you create this thing successfully. So all day long, I've been talking about you can shove in foo equals bar and all that kind of junk. Not the case anymore. Now that this validation is in place, that again, you saw me not write. You saw me just inherit basically from the types file, which I had to write and Go anyway. I get this validation essentially for free. And then this is kube level validation telling me your resource is not valid. I'm not even going to accept it.
Can you specify like or make a default or an optional like value there and like say like, hey, this is going to give you default size of 3, but if you don't specify size, like that's the default inherent value?
Yeah, so what happened is when it generated this, it filled out this required area.
Yeah.
I'm 99% positive I could have put clues inside the struct code in Go to have it not be included as required and have it be defaulted. I don't know what that looks like. I don't know if that means defaulting it in the struct itself. I don't know if that's even mechanically possible in Go because—
Or make like an initializer function if you have to do that and check if a value exists or something.
Yeah. I'd be willing to bet that this is accounted for. I just don't know how to do it in Go, and it's probably not tremendously well documented, but I know who to ask. And you've got me kind of curious because that's a cool mechanic.
You could do that in Ansible too, right? If you're using that, like this but that's a more Ansible focused question, I guess, right?
It is and it isn't. So what we didn't do this step for Ansible or Helm, but we would also want to, is manually writing out the validation in the CRD. We just didn't. Because due to time, I don't want to repeat that every time. And the Go example of it is actually really cool because it generates it for you from the type. But if we were productizing the two that we wrote earlier, the Helm and the Go, we would clean up the RBAC stuff to make sure it's as restricted as possible. We would also have flushed out the validation in the CRD because it's still useful. It's still useful at any time to show, hey, this is how you actually create one of these and give you those clues. And then again, if we look through the CRD itself within Kubernetes, it's going to tell us this information too. So I'm packaging and delivering this API such that the user can consume it directly through Kubernetes, not just by making the API calls, but by this kind of reflection-y concepts of looking into the CRD itself. And you see how the jump we wrote in earlier. Wait, where am I? Oh, I'm not in VI. Okay, so now that that's set up correctly, wait, I forget if I set it up correctly. I did, okay. We'll create the custom resource. Now you can see here, it zoomed by pretty quickly, but there were the log messages saying my SQL isn't running, we're waiting. And that's triggering that second reconcile through. It ultimately resolved pretty fast because, again, the images are downloaded. They're all pretty lightweight. And we get everything back up to speed. So we get our pods, we get our services. I'm going to change this. Let's do pod service visitors.
That's a lot better.
Based on Rails. Yeah, and like deployment, you don't need to see deployment because it's implied by the fact you're actually getting pods. Technically, it's not, but it's close enough. But now that I know I can do that cool comma separated, I kind of dig that as the approach. Back over here, 3686. And we have our Go-based operator. And just like last time, we can edit the resource. And we hit edit, we immediately jump over, and the log messages are scrolling by with, and unfortunately, oh shit, what's that flow called when water flows and you can't see like it's actually moving? Lamar flow?
No. That's really close though.
It is kind of close. Water.
It's a laminar flow.
Is that what okay. Laminar, yeah, Lamar. Okay, close enough. Oh, so we have a laminar log right now, which is not actually a thing, but I'm going to make it a thing, where it was moving, but it was moving in such a way that we saw the exact same message. Anyway, I feel like that should be a concept though, because that
really should be, because that happens a lot.
It has happened a lot. You're like, I don't know, and then you highlight it, and you see the highlights disappear, and you're like, okay, good, we're doing something. Yep. So laminar logs to show that it got the request. Hit refresh, and we see to you too, Brian. Now, I've shown that demo twice now, but where it updates it. This one is arguably more impressive because we had to do that logic to be smart. We had to have this logic that said, okay, I've got an update to an existing resource. I'm not going to create new pods because those pods already exist. But I am going to look at the existing configuration on those pods and what's currently requested on my resource, and I'm going to make sure they map up. And it's that whole desired versus actual thing that you hear in virtually any Kubernetes architecture type discussion, where we have a desired state that's handed in the resource. The operator needs to understand what the actual state is and then reconcile the differences. So from an end user perspective, looks like the stuff we did earlier because the Ansible and the Helm operators do that for us. Here, actually, I should say Ansible itself does that for us. But here we had to manually do that, which is not impossible, not even necessarily difficult. I mean, depending on your application, but very cool that it works. And I didn't run into it, but I can totally see an issue of me writing a bug when I create one of these that I'm not doing my check correctly. And every time the reconcile hits, I get new pods and it starts spawning out of control. Would not surprise me if I accidentally ran into that. So, holy crap. That's Go operators. And I know I glossed over a fair amount of the code I guess I could do this. I'll put it in chat. GitHub. So if you go under my GitHub account, github.com/jdob, all of the repositories that begin with visitors are related to this. So there's the repos for the backend and the front end code itself. There's the repos for the operator, the Ansible operator, the Helm operator. And then there's a repo called deploy, which is really just all of this stuff broken out. So it's the actual just Ansible role by itself, the Helm role by itself, manifest by themselves, just so I had a place for all of those as well. But any of that you need to follow along on, or to dig more into the code that doesn't really play that well over Twitch, because going line by line is not terribly interesting. It's much more interesting to me to get the concepts that we constructed the object representations of these resources. We called the pre-authenticated client to say create them. And then we had a few other kind of cool logic pieces in terms of, is MySQL running? No. If not, we're going to wait and then do a reconcile again rather than blocking. And that's a good takeaway too, though, is that your reconcile method should never block like that. You should just give up the resources and then let Kube try again when it's ready.
So like getting to some of the basics, like, if I'm an application developer deploying an app and we're going to run it on Kubernetes, why do I need this? Or what else could I use, I guess? Like, what's the alternative?
Depending on how complicated your application is, the alternative may honestly just be manifests, and you can avoid this entirely. For instance, this site, you probably could just deploy via manifests. It's 3 pods, it's a very little crossover. I mean, if we wanted to generate a unique MySQL password and then pass that between them, that takes some effort to do. Are we frozen on Twitch, or is it just my particular video?
The video gets stuck every once in a while, but it comes back. Or if you just refresh the page.
I wasn't sure if, yeah, exactly. I wasn't sure if
it seems good here.
All right, cool. Just a second. Okay, I'm getting an ad now because that's what I need to add my bandwidth. We can see there's probably a less stalkerish way of phrasing that, but I appreciate the sanity check from chat. Alternatives, manifests, and then from there on out, for anything more complicated, the alternatives are you put it on the user. So the title and the size in these examples go to 2 different deployments because they're for 2 different parts of the application. My user doesn't have to know that because I've given them this visitor's abstraction on top of it. Other implementations, like if I had multiple manifests, I would have to tell you, go into the front end one and edit title, and go into the back end one and edit size over there. Ansible does skip some of this. Helm, I'm not that familiar with Helm, so I'm probably downplaying its capabilities. But I was able to deploy this site purely based off of Helm charts. So this is not the greatest example for where it's needed. The problem is the really, really good examples for where it's needed are too damn big to write in a talk like this. So think back to the Kafka one where we had fairly complicated-ish logic of the zookeepers have to be up, and then when you add a new pod, you don't just spawn up a new container, you also have to add it to the cluster and make sure, no doubt some other black magic is going on, so it's part of it. That then can be extrapolated to any database that runs in a cluster where you don't just scale up a pod. So let's say the Couchbase, for instance. If I had a Couchbase instance that I manually deployed and I scaled it up, I'd have to scale the pod up, doable. Then I would have to go into the Couchbase UI and register it as an actual part of the cluster and trigger the rebalancing operation, whereas the operator will do that for me. So to ultimately answer your question, where does this go if not in an operator? It goes in the user's hands. And users are dumb, and we don't want it in their hands because users will screw it up.
I mean, like, I think this gives, me as, say, I'm making an application on Kubernetes, like a way to do what you're saying. Like, my application requires, MariaDB. We saw the operator on Operator Hub. Granted, it was a really early version, but we saw that, and it's being made. So I could basically, wrap my application, just install it using Ansible. If I know YAML, I could figure that out. And I could use the K8s modules and stuff to make my own operator with Ansible to deploy my own app. But I also could say with like the operator like framework that, hey, I'm relying and dependent on MariaDB. Go and install that for me. That's part of my, like, I need that. That's a dependency I have, versus the other way, I think, without me making an operator would be like, oh, hey, to deploy my application, you have to go deploy this operator yourself from MariaDB manually, or go, give me a manifest to deploy it. And then that's not managed by an operator because I'm running MariaDB pod by itself, and it's, not that great, versus the cluster managing it the right way. So like, I think there's a lot of value in that use case. You know what I mean?
Totally fair. I think that the user is a smart argument going on. And you're right. It's if you take operators completely out of that equation, you also have to have someone to install and administer the MariaDB part of it and know all of that as it runs forward. So even without, if you go further, and instead of saying, all right, I'm going to install this application and then manually do the MariaDB operator, if we didn't have that entirely, you're extending all of this operational knowledge that, we have slides that I've used before that literally, the title of the slide, I'm sure this is a quote from somewhere, but it's anything that's not automated is slowing you down. And they don't attribute that quote to anyone. I got these slides from Jorge, actually. But the point absolutely still stands that, this is stuff that if you put it on the user, let's say your users, you're smart enough to use our software, accidentally fat finger something, you take that out of the equation by having it all programmatic.
I mean, yeah, completely agree. Like, one of the fundamental aspects of microservice approach of like getting applications running is, hey, we have like a pod, one process per pod. Like, that's a not a requirement, but like a general good practice. And then talking about that, like, we should be able to automate everything, including the deployment of what we're doing. And how do you automate everything when you're specifying manual templates and manual manifests for that application? So generally, automating everything requires doing something. You have to at least think about how you're gonna do that. And I think that, yeah, the operator approach is a good way to do that, but that's one of the good practices to be able to have an application running at scale on your cluster.
So just to completely derail the conversation, we had a question in the chat asking the best practice for authentication authorization in a cluster. That was it's a higher level conversation, which it seems that we've kind of covered anything, but was there anything like, if somebody came up to you and asked those questions or that question, what would you say to them in a 30-second answer? It depends.
It depends. Sadly, that's the cop-out answer, but the real answer for almost everything. Because I'm going to give you more than 30 seconds. A lot of times I get asked like, oh, what does the common OpenShift deployment look like? It varies. What are people using for such and such a solution? It varies. And it's, on one hand, I would go back to the typical argument of there's no incumbent yet, that this is all a fairly new area. But on the other hand, it's just the nature of how flexible it is. There are people who relate it to the Kubernetes layer to almost the new operating system. And whether or not you buy into that, let's say you only 10% buy into it, it's still like asking the question like, well, what is the best practice for running RHEL? Well, it kind of depends on what you want to do with it.
And like what your security model is and all that stuff. Like, those are all valid points that like it depends on what you're trying to do, right?
Yeah, and don't be sorry about that question. It's because it's valid to hear that there is no set answer. That's just as valuable as me saying, "Oh, the answer is clearly to do blah." It goes to show that this stuff is that flexible, and which is good. There's no real lock in there, and we've seen people kind of pick and choose the pieces and how they want to integrate. And I don't want to pull up the landscape picture again, but you look at the CNCF landscape photo, and that kind of helps show that there's no set best way of just about anything at this point, because everyone's got their own spin on it. Yeah, shit, that sounds negative. I don't mean it to say that everyone's got their own spin, that they're just kind of personalizing and making proprietary, but everyone's got their own different approaches and their own different values. And in a lot of cases, it's so easy to talk about these greenfield deployments of you're starting from absolutely nothing and you can make all your choices. And the reality is you're going to get thrust into a situation of, well, this is cool, operators sound amazing, but we already are invested in Ansible. Or, this sounds amazing, but we already have, Prometheus sounds amazing, but we already have this contract with Dynatrace that we've been, extensively buying into. It's like, okay, well, that's where the partner ecosystem comes in, and you see what their offerings are, and then you kind of build up your own solution from there. But like I said, that's definitely not something to apologize for, because knowing that the answer is open-ended is still very much an answer. That no, there's no single thing. You figure out what works best for you, and it's probably right, or at least works until it doesn't, type of thing.
What's the joke about being a difference between a senior and a junior and a senior engineer? A junior engineer thinks they know everything, where a senior engineer realizes they know nothing.
I like that. I thought it was going to go to like a Stack Overflow usage question, but that works too.
Yeah.
But it's true. It's so true that, even the senior junior thing, because like, I feel like on the stream we've talked about, like, we've definitely joked about the holy wars of like the Emacs and VI stuff. And I just, we poke at each other for it. But, as I hit senior level, I started to realize that there's no really wrong answers. That's probably a bad way of saying it. There's necessarily right answers in most cases. And that kind of realization that it's good to know that Phoenix, yeah. And like he says, this for demo purposes, it's so hard to draw that line, because it was absolutely atrocious that I hard coded the password. But do I take up screen real estate showing some sort of password generation thing and where that maps up? Pros and cons. But this all goes all the way back to the beginning of kind of learning people's presentation styles and like what you take out of it. Being able to draw those lines and say, yep, this was specifically for demos. Do not do this. This was kind of a taste. All of this Go code, you would probably want to get an actual Go developer to do correctly. And if you look at the Operator Framework is a GitHub organization with a variety of repos underneath it. They have sample and community operators, and you poke around there and they do all sorts of wildly different things that I've done here. Because again, this was written for the book, so I had to find something I could cram onto a page-ish, or at least snippets of it. So some of it is structured around that too.
There's another question. Brian, maybe you can take this one. What are the best books to learn Jenkins, Ansible, or Kubernetes, but already have some system administration knowledge?
So they're like one of the probably better ones that I've seen. That we were doing, I think maybe it was last year we gave out at Red Hat Summit. It's more written around OpenShift 3.11, but those concepts, exactly what you're talking about, is pretty much the same. Like, I wouldn't imagine there's very many differences. Is OpenShift for developers. So that's another book that we have available. I probably could get a link and put it in the chat. So that's one that'll go through and tell you kind of, some of the things that you would need to do to set up an application and deployments. I think it even talks a little bit about builds and pipelines. I'm not sure if it touches into Jenkins, I don't remember, but that's available, and that's one thing. I know that we also do have some learning examples on building out applications, learning OpenShift specific things. There you can see it on that page, OpenShift for developers. There you go. Free ebook, you could download that, and it's available. Just copy that. That's a good link. But we also have some example learning paths that you could get hands-on stuff. I know I do really well in actually seeing it work, and actually typing the commands on the keyboard. And through that, just go through learn.openshift.com. And in there are a specific set of building applications on OpenShift. And all of those examples are exactly what you're looking for. So using OpenShift specific things, like using a project instead of a namespace, and using other, OpenShift specific things, routes instead of load balancer, ingress, all that stuff, are a part of those trainings. So that's one of the really good areas. So learn.openshift.com.
Nice. I answered it completely differently, which was, I was like, there's a lot of information online around the different projects, and nothing stops you from just using them. A lot of the stuff is experience. Like you need to get your hands dirty. You need to find the different ways to play with the technologies, and nothing, like, you can't learn a lot. Like, don't get me wrong, as proven by Jay's insane amount of knowledge about operators, books are important, and it's good to learn the stuff via books, but there's nothing, like, you still need to get your hands on the code, on the projects, to actually see how they work. It's not academic, right? Like, this is not academic. You need to play with this stuff. Nothing's better than experience.
So to that point, I mentioned my private or my personal GitHub repository earlier. I also, within the book, a lot of it is just kind of moved over there and broken out per chapter, but a lot of the same stuff is available there as well. To kind of echo JJ's point, like, most of these books, and I forget who was the college student in the chat, so I don't know if this is relevant to necessarily who is asking this, but a lot of times these books will have a lot of the code online in repos, and it's really, really useful to download it and run it at the same time, and then just start dorking with things. So a lot of times when I'm reading these books, I'm like, well, wait, what would happen if you changed this? Because they didn't explain that line, and I'll go and do it myself. So when you're using these books, if you go the book route, and JJ is completely valid about online resources too. I don't make my students buy a textbook. I'm like, guys, if you don't understand what I'm saying about Git, Google it. Like, you'll find someone out there who can explain it in terms you'll get. I'm not going to have you buy another $200 textbook at college. But the same thing for like these books. If you do go that route, most of the time they will have that source code available, so you're not retyping it, and then you can follow along and then just start messing stuff up. And I've known people, I'm kind of the same way, where I'm like, I learn kind of by screwing things up. And I'm like, well, this is cool, but what happens if I do this? I'm like, oh shit, it burns. Don't do that.
Or just watch the IBM developers stream, where that's what we do. Yay!
Is that how we're ending it? Because that seems like a really good way to end.
That's a pretty good place to stop. That's great.
Please stop the sharing, because we don't need any more of that.
There you go. Any last thoughts, gentlemen?
For me, just thank you all for listening. That was 3 hours of rambling on my part that I hope was useful. The questions, the chat was very engaging. That was super cool. I always love hearing from you guys. And that's all from me. I'm about to go start my weekend.
That works. Brian, what do you got?
No, I thought it was good. Yeah, I definitely kind of like the way that you went through. I think that Git idea is good to like get going to make it flow smoother. But I think that, like, for the most part, content's pretty awesome. Like, I like it. Awesome. Use operators, everybody, or at least something to automate your deployments, right? Think about it, at least. It's important.
And actually, that's a really good last question. Does OpenShift have a Slack that we should use? It's the OpenShift Commons one, right?
That's probably your best bet. Let me
I agree. I think that's probably
because I started typing out an answer to say, that should be a lot easier to answer than it actually is. Because I'm on like 5 of them, because like every little team's got their own, and on top of that, like there's still probably not in this group, but there's still people using IRC.
There's like on Slack, there's kubernetes.slack.com, which there's an OpenShift dev, OpenShift users channel. There's the OpenShift Commons Slack, which people do monitor as well. So you could look in there. IRC, exactly what you said. I know that I think it's just OpenShift on Freenode, but I'm not sure.
What's that XKCD? Let's say XKCD. We have 13 different standards. So we decided to come together for another one. Yeah. Now we have 14 different standards.
Yeah. Some of those, when those hit, those are so accurate. Yeah, that's exactly it.
That is the truth with chat.
Yeah.
Yep. All right. Well, I guess say bye, everybody.
Thanks for hanging out, everyone.
Yep.
See you next week.
Oh, see ya. Have a good weekend, guys.
Do you want to post your contact info in the chat before you go, just so people can get a hold of you if need be?
Yeah. Shit, I already logged out.
No worries. It's cool.
It's the easiest way to do it. It's on my GitHub repository. So I had posted that earlier. There's an email, and you can file issues against those relevant repos as necessary. You can definitely find me from there. Twitter's the same thing. Twitter, let's do that. JDob on Twitter, the same as my GitHub handle. And reach out to me in there.
Ryan?
I will post mine in the chat.
Perfect. All right. Now on that note, bye, everybody.
Bye, guys. Have a good weekend, everyone.